Oh, hello. Good afternoon, ladies and gentlemen. So we'll resume our afternoon sections. Uh, for our next speaker, we have Philip and Jeanette from BrainBot. Tell, they will talk about Raiden Network. Let's welcome Philip and Jeanette.
Hallo. Okay, so hi everyone. My name is Yannick and I'm going to talk about the Raiden Network, and in the second half of the talk I will hand it over to my colleague Philipp, who will then talk about MicroRaiden. I have to start with a little disclaimer. I've actually not worked on the Raiden Network myself, so I might not know every implementation detail, but let's just start. Okay, so one of the main applications of blockchains, of course, is payments. We want to transfer tokens, for example, from Alice in Brazil to Bob in Australia. And we do this by basically using the blockchain as a kind of global database where we don't need a central party for that. And we put every transaction in this global database. And so basically we replicate every and this means that we replicate the transactions on every node in the network. And this is, it works, but it's kind of inefficient, which means that transactions are expensive. The users have to pay for gas to do this. It's also, from a global perspective, not scalable. The network can only sustain a certain number of transactions per second. And if we want more than that, it's just not possible. Also, privacy is a problem. In many cases, we don't want to have the transactions replicated. We don't want that everyone knows that Alice paid Bob some amount of money. And a third problem is finality. And this replication process takes time. The network needs to make sure that there are no conflicting transactions, and this process just takes a couple of seconds or minutes, and this is often just too slow for everyday payments. And these are the problems that the Raiden network tries to solve. And it does so by using a technology called payment channels. The idea is to take a lot of computation off the chain. In this payment channel, the blockchain here is on the right side, and the payment channel is separated from it. And all the communication happens between only the two parties, Alice and Bob, and not on the blockchain. And therefore, we don't have to pay for gas, because only these two parties are involved. It's also private, because only Alice and Bob know what's happening inside the channel. And it's also finalized very quickly, because as soon as Bob receives the payment from Alice, he knows that he got the money. Let's look at it in a bit more detail, how a channel works, how a payment channel works. First, we need to open the channel, and for that we need to lock tokens on the blockchain. So this is an on-chain transaction. We have to start with an on-chain transaction. And in this case, for example, we have Bob who deposited 3 tokens, and we have Alice who deposited 7 tokens. And then, after that, the actual life of the channel starts. Alice and Bob exchange so-called balance proof, which are signed messages of the new balance in the channel. So if Bob wants to send 1 token to Alice, he signs a message that he has only 2 tokens left, and the next one, he has only 1 token left. And if Alice wants to send tokens back, she does it in the other way around. And these balance proofs are signed messages, so both parties always have cryptographic proof of how many tokens they have left, and they can go to the, in the end, if they want to get the tokens back, they can go to the smart contract in which the tokens are locked and submit these balance proofs and to claim the tokens and to get them back. And for that, they have to close them first to start the settlement period so that the other party has a chance to get their tokens as well. And in the settlement period, yeah, they can claim their tokens then. And then the channel is closed again. Okay, so that's how it works. There's one problem though. For this, if you want to do payments, you always have to open a channel. And if you want to open a channel with everyone, you want to pay something, this just doesn't work because you won't have enough tokens. So what we need is basically a network of tokens, a network of payment channels, and that's what makes the Raiden network a network. And in this example, for example, Alice and Charlie. Alice wants to pay Charlie some money, but there's no open channel between them. So what they can do a so-called mediated transfer. They know that Bob is connected to Alice and Bob is connected to Charlie, and using mediated transfers, they can route their payment via Bob to Charlie. And this is important property. This is secure. It's not, Bob does not have the ability to steal the tokens on their way.
So how does Bob know they're connected? How Alice knows that Bob connected to Charlie?
Yeah, that's a problem. There needs to be some routing mechanism there. I mean, these channels are publicly known. They are all in the blockchain. They all have been opened at some point. So in principle, all information is available. But finding these paths is a little bit difficult. But it's solvable. Okay, so that was how it works in principle. We have released a developer preview on the Robson testnet where you can try it out, and we would be very happy if you try it out because then we can get feedback, and you can open GitHub on issues on GitHub if stuff does not work. So we invite you to test it. And to do this, you will need a Linux machine, or very soon there will also be a macOS release. You need an Ethereum node, which is synced on the Robson testnet, where our contracts are hosted. And yeah, then if you downloaded the Raiden client, you can run the Raiden client. And when you do this, another thing you need, of course, you need a token. And we suggest you use the Raiden test token, which is deployed at this address. There's a simple mint function which you can call to get these test tokens. And yeah, once you have some, you can use it. There are two ways you can try it. There's the REST API, which you will need if you want to build applications on top of Raiden. But if you want to use it as a human, you can use a web interface. And for that, we have a video which shows how it looks like, and I will walk you through it. If it looks like it's working. How can I turn off the sound here? Okay. So this is how it looks like. Here on the left side, you can see the tokens view. If you click on it, you will get a list of all tokens that are registered. At the time the video was recorded, there were only 3. But now there's a lot more, so you have to look a bit for the Raiden test token. And once you've found it, you can click here on the Actions button, Join Network. It will ask you to specify the amount of tokens you want to use to join this network. We will use 500 here. And now these 500 tokens will be used to open channels to other people, because we want to participate in this network, so we need channels to several parties. And this will use now 300 tokens to open channels to other parties, and we will keep the other 200 tokens in reserve to be able to make bidirectional channels. If someone connects now to you, you have some tokens left to make a connection in the other direction, which is a nice thing to have. Okay, and once now all channels are opened, we can click here on the right on Actions and yeah, start transferring tokens by simply clicking Transfer, Transfer to Tokens, click on Transfer, and then yeah, almost immediately the tokens will be transferred in this payment channel. Yeah, and it's doing now a couple of times. But the interesting part, where Raiden gets interesting, are of course mediator transfers. And to do this, this is even simpler than that. You have to click on, go back to the tokens view. Exactly. Click on Actions again and transfer. And then you have to specify the address, which you are hopefully not directly connected, but connected via a certain path. You have to, again, specify the amount, and then the application will find the path on its own, and yeah, do this transfer. And as you can see here, now the channel that did the mediating is now, now has a reduced balance. Okay, that's all from the demo, and now I'm done basically. Ask you again to try it and to report all bugs. And yeah, that's it. Now I hand it over to Philipp. Thanks.
Thanks, Yannick. So from Raiden Network now to MicroRaiden. What is MicroRaiden? MicroRaiden is not Raiden Network, but let's just think of it as the smaller sister of Raiden Network. So MicroRaiden is a robust payment channel framework which you can use off the shelf. It's making for already, maybe you can use it for about 80% of the use cases that you can think of with payment channels. It is basically unidirectional payment channels, which mean transfers from sender to receiver only, which makes for a use case of many-to-one payments. Since it's not a network of payment channels, as Yannick was talking about Raiden Network, but just this simpler setup, you don't have these issues that you have with Raiden Network, like a channel watching or a pathfinding, like your question was about. And because you don't have these issues, it's basically fast and free for off-chain transactions. Maybe the most interesting part is it is already available on the Coven testnet, and it will be available on the mainnet by the end of next week. So for what could you use this MicroRaiden? Basically, I try to sum up some of the use cases here. There are more, but these are maybe my favorite ones. So first one would be pay-per-use. If you have a simple payment implementation with a many-to-one relation, what you could do was, for example, you could pay your favorite news websites. You can go to a news website, pay for an article, then pay the next article, and you don't have to pay on-chain gas fees because you have a payment channel opened with this news website, and many other people also have a payment channel with them. So you could also think of video streaming, for example, as this pay-per-use model. You could pay by minute or by video. Maybe the favorite example is pay-per-request APIs. So think about you have a API and you want to monetize it. So now there is a way to actually be able to do that. I, as a requester, I want to request the API, and I send you a token via, I open a payment channel, I send you a token via payment channel, and for every request that I make, I send a token, and then when I paid, I get access to the API per request. Another good example would be, think about a future where you were able to access Wi-Fi hotspots all over the world, and you would be able to pay for Wi-Fi hotspots, so there is no log-in, something like this. You just pay with your token, and then you can access it. And on the other side, you can monetize your Wi-Fi hotspot, right? Besides, your question? Sorry? Supermarket? Is that a question? Yeah. Sure. So basically, I'll get there in a minute. Another use case for IoT would be sensor data. So you just pay for the data you receive, and you pay and pay many small amounts. So the question was supermarket. To sum it up, every time you think about recurring micropayments, so where one set of people, or maybe one people, many senders want to pay one central service, you could make use of it if this payment is reoccurring, right? So in a supermarket, of course, you go to the supermarket and you would be able to pay it just like you are with cash. To show you how it works, we made 2 demos, and you can actually try it out if you go to demo-micro.raiden.network, get some Coven testnet ETH, and you will be able to use the demo, which shows a distant future where you have to pay to visit Wikipedia, and the paywall is paid by microtransactions. So every time you visit a new website, you can pay. Maybe Wikipedia is a very dark example, but think of it as a news website where you can pay, as I said before, per news site. Every time you visit a new article, you pay per microtransaction. So please try it out. And the second is a video we have online, which shows the example that I was talking about with APIs, paying for API queries. Another example would be a robot that you fuel with micropayments, and that's actually what I want you to show right now. So let's see if that works. Maybe Yannick, you can assist me to hold the microphone. It's kind of hard with only 2 hands. Okay, let's see. So what we made was a setup. What we have here is basically, and let's see if it works, a micro-Raiden server, which is basically the server of the robot car, which is going to receive the payments. And what you can see on the upper right corner is the Coven test chain syncing. So let's try to open a channel from my sender address to the micro-Raiden server, so the receiver. It actually works. That's quite nice. What you can see, maybe it's hard to see. Thanks. There, I opened a channel with the micro-Raiden server, and in the right corner you can see the micro-Raiden server registered a new channel. We actually see here the transaction hash, and we should be able to look it up on Etherscan. Because, as Yannick said, basically when you open a channel, it is a on-chain transaction, right? Opening of the channel, closing of the channel, and if you want to deposit tokens, it's on-chain transaction. So what we see right now is we triggered this on-chain transaction. And yeah, thanks, Yannick. and it's actually mined already. So we should see that we have a channel right now. Okay. So what I'm doing right now is I want to deposit more tokens. I say I want to deposit 25 tokens. I click the button, and there is one on-chain transaction happening. What I don't see is the confirmation on the micro-Raiden server, but let's see what happens. So again, as the opening of the channel, as closing of the channel, depositing is also a on-chain transaction. So we are able to see it on the real Coven test chain, which means we have a channel right now. Let me reload the site, which has a, okay, reloading the site doesn't help, which has 25 plus 20 tokens in it. Let me just quickly restart MicroRaiden, but sometimes it just takes a quick reboot. So let's see what happens. And if my client side works, then actually we would be able to control the car. We are good in time, so let's just try it out. So it could be that the connection is not too good. So I will probably not be able to show you the car driving, but we have a video online where you can see it. Let's try it out. One more time, and if this doesn't work, then we can show it to you later, guys, after the presentation. So I think, thanks Yannick, to keep you awake, we will just move on. Let's try it out after the presentation. Actually, it did work today, but sometimes it just doesn't like to move. So what would happen is you would be able to see the car moving with the token transfer. You open a channel, deposit some tokens, and with the transaction of a token, you see the car moving. And if you don't pay the car, it doesn't move. So please look at our code, play with it. We have the MicroRaiden GitHub repository, and we have a, you can find how to use it there. As well as the robo car demo. You can come to me and ask how it works, how it actually works. So actually, what is it about? I think I can quickly talk about it because, I mean, basically it's the same technology than Raiden Network. It's not part of the Raiden network itself. It will be part to pay service providers, but it's for itself a own product. So it is the it is a off-chain payment channel as Raiden Network is. So the transfers itself happen off-chain. What you actually have on-chain is the sender and the receiver both have the channel data. The channel data is says who is the receiver, who's the sender, what's the block number when the channel is opened, and the current balance. The receiver not only has the channel data, but also the latest balance proof that happened, basically the transaction that happened. So a balance proof is basically a signed message signed by the sender, which says with the information receiver address, with the information of the block height, what block number did it happen, the transaction, and the balance. When the receiver receives the balance proof, then this is already a finished transaction. He knows that he owns the tokens and that he is going to be able to hold the tokens on chain. So he will provide the sender the resource, such as a website, for example. From the opening and transactions to the closing. So how does a closing actually works? I mean, there could be a cooperative closing, and there could be a closing where sender and receiver where they have an argument, basically. What would happen in a cooperative close is the sender would request the receiver to, with a signed balance proof, to send him a closing signature. The receiver sends a closing signature, and with this closing signature, the sender sends a transaction also including block number, receiver, balance, and a signed balance proof to the channel contract itself. And the channel contract is simply sending back the tokens that are left in the channel. So the sender didn't send 10 tokens, so 10 tokens are left, and he will get it back. And then the channel is basically closed. So to sum it up, MicroRaiden is ready to use. It will be on the mainnet end of next week. It is the go-to solution for 80% of the use cases for payment channels. Because it isn't that sophisticated as a Raiden network, because it is a many-to-one setup, it is fast and free token transfers, and you would basically use it for microtransactions, as we said. So please play with our demos, have a look, and try it out. And if you have any questions, please ask. Thanks.
For our next speaker, Loi Luu from Kyber Network. Oh, it's Kyber. I'm sorry. My bad. Didn't do my homework. So Kyber, Loi Luu. Welcome.
If you already attended the blockchain summit in Taiwan yesterday, it's going to be the same talk. So, but I think I will have the demo. So just stay and see the demo if you are interested. It's on. Right. So my name is Loi Luu. I'm a CEO and co-founder of Kyber Network. We are a decentralized exchange which runs entirely on chain, and today I'm going to talk, I'm happy to be here and present and introduce you about Kyber Network. We are based in Singapore, by the way, but we have like different teams in different countries: Vietnam, Israel, Australia, Malaysia, and Greece. So it's pretty decentralized, right? So in the past few years, right, we have seen the extraordinary rise of cryptocurrency, and today, today our market cap is like 260 billions, and it keeps increasing. And the number of coins and tokens that people are minting, I think like 2 years ago we have only like 3 or 4 coins, but today we have like more than 10,000 coins already. I couldn't keep track of them anymore. So this is just to say that we have more and more coins, and the needs for converting and acquiring the coins is increasing as well. And if you look at this chart and you see some anomaly, right? Like in 2014, the market cap just like dropped from 11 billion to only $5 billion US, and many people think that it's because of the market correction, it's because of the changes in the regulation. But there was a major event back in 2014 that was Mt. Gox. So Mt. Gox couldn't, in case you don't know, right? Mt. Gox was the exchange back in 2013, and they processed I think more than 90% of the Bitcoin trading back then. So in late 2013, Mt. Gox couldn't answer what happened to 800,000 Bitcoin of their users. They claim that they got hacked, but many people just think that the exchange couldn't manage the asset, and they just converted everything to pay for the expenses. But no one knows what actually happened, and millions of users got affected. And Mt. Gox is not the only incident in the centralized exchanges, right? Over the years, we have like all the major exchanges. They either got hacked or there's some internal fraud. From Poloniex, Bitstamp, Shapeshift, and Bitfinex, and recently we have the Tether, right? The Tether incident that 30 million of Tether got hacked, and this incident happened like so frequent, and people just like lose faith about all these centralized changes, because it's just like due to the nature of the centralization. Centralized changes will either get hacked, or some of the internal staff they just go away with all the user deposited money, right? So this is against the nature of like cryptocurrency and blockchain, in which we advocate for a trustless and decentralized environment. So that's why recently we have seen a lot of like decentralized chains which are building on top of Ethereum. So we have like EtherDelta, 0x, Kyber Network, Omisego, SwapTech. So I'm not going to talk about the details of all these exchanges, but this is the roughly the brief comparison between all the exchanges. So the properties that I choose here are a little bit biased, because I just want to I just want to tell the difference between Kyber and all these other exchanges, right? So on one hand, we have like EtherDelta, SwapTech, and 0x project. They are not entirely on-chain. So what they do is they have the concept of like off-chain order book, and every time if there's a trade happens between the buyer and the seller, the settlement will happen on-chain, right? And essentially, the user they have like to trust the relayers or the website etherdelta.com, and if these relayers or website got compromised, user they probably lose their money. Omisego is different, because it's going to be on a side chain or on the plasma chain, which is eventually get committed to the Ethereum blockchain. The main advantage of doing that is that Omisego can offer higher transaction rate. But of course, So Kyber, for Kyber is we run everything on chain, and so the user, they just like interact directly with the smart contract, and they do not have like to trust any centralized entity like website or relayer or anything. And we have a different concept in which we can guarantee the liquidity. So every time you want to trade, you can just go to Kyber and you can trade your coin and be done with it. One downside is that our scalability depends directly on Ethereum, which EtherDelta, SwapTech, and 0x also share the same difficulty. Right. So I'm gonna talk a little bit more about Kyber Network and how we built our exchange. Right. So a quick introduction about Kyber Network. We focus really on both security and usability. So we want to offer instant and secure trade with guaranteed liquidity. So this is the only exchange, only decentralized exchange that can do that. Apart from that, we are also trustless. So that means you do not need to trust Kyber, or you do not need to trust a website when you trade with Kyber. And because we run everything on chain, so we offer the high compatibility. If you want to integrate Kyber with your smart contract, with your DAV, it's really easy because you only need to talk to the smart contract. You do not need to query any server at all. Right. So how do we do it? So we realized that if we have any off-chain component, first of all, because we have to rely on that off-chain component, then there's no so essentially user, they have to trust that off-chain component, right? And solution like 0x, EtherDelta, they do not provide any settlement guarantee, because it may happen that the website got shut down, or the internet connection is bad, and someone get the trade before them, so the settlement is not guaranteed at all. And if you have some off-chain component in your platform, then it's really hard for other projects to integrate with your platform. So the compatibility is low. So that's why we built Kyber Network entirely on-chain. So we just have our contract, and you just interact with the contract if you want to trade. And the second major decision that we have in Kyber is that we remove the concept of order book. So you do not see any a lot of orders in Kyber Network. We realized that if we push everything, the entire order book on chain, then it's going to be, first of all, expensive for the users, and secondly, it's going to blow up the entire storage of the blockchain, right? Because if you have millions of users and they're trading millions of trades per day, then the entire blockchain is just cannot afford it. So what we do instead is we introduce the concept of reserve. They are similar to the banks in real life, right? So these banks, this reserve, they have a lot of coins and tokens, right? So this will guarantee the liquidity. So when you want to trade, you go to the reserve, you ask for the rate, right? And if you're happy with the rate, you just go ahead and trade. So we also have a mechanism to bring market makers or people who introduce reserve in our platform, so they can earn profit from the spread, from the trading spread, right? And we also provide sufficient tools and software for the reserve to run, so they can just easily do it without much technical background. And we're also working with popular wallets and platforms who have a lot of users, so that we can integrate Kyber with this platform. And through that integration, we can generate a lot of traffic or a lot of trade in Kyber Network. So I just want to explain the simple flow of a trade in Kyber via this example. So we have the Kyber contract that is going to receive all the requests from the users, right? And we have the reserve that is going to provide the liquidity. And if the user wants to trade from some token A to token B, the user just like send the token A to the contract, and the contract will just like credit the token to the reserve, get back token B according to the rate, and send the token B back to the user. And everything is done within one single transaction. We have other components like the reserve manager, who is going to manage the reserve, deciding the price between token A and token B. We also have like Kyber operator, who is going to add and remove more trading pairs, adding more reserve in our platform to support other tokens. Right. We also allow like multiple reserve to register in our platform. So if you just have some idle asset, right, like coins just sitting in your wallet, you can just like register with Kyber and be one of the reserve in our platform, so you can like earn profit from all the trading happening on Kyber. And with this many reserve, we can offer actually better price for our users. So if the user wanted to, for example, if the user want to convert Ether to Omisego, we just like talk to all the reserve that are offering the same pair and get the best price for the user. And the user will just like enjoy the more competitive price in our platform. So we did our token sale back in September 2017, or 2 months ago, and we are targeting to launch on mainnet by early next year. So I just want to give you a quick update on the progress so far. So we have 3 important components: the wallets and platforms that are going to integrate with Kyber. So the main purpose of this component is to bring more traffic to Kyber Network, and also make it more convenient for the user to convert and trade between tokens. We also have the smart contract components that are going to receive the requests from the users, that are going to maintain the reserve and also support the operator as well. We have the reserve dashboard that are going to have the reserve operators to make price, get the market view, maintain the reserve. So so this is our current testnet wallet. Our current website that we support, trading with hardware wallets. I can just do a quick demo to show you like how simple it is to trade with Kyber. Right. So this is the website when you see it, and you only need like to submit to unlock the wallet. This is running on Kovan, and you will be able to select which pair that you want to convert. So for example, if we want from Ether to Omisego, I can just buy. So you will see the rate here, right? Between the rate between Ether and Omisego here. And if you want to configure the the gas price and the gas limit, you can also do it. Otherwise, you can just like click on exchange, enter your password, and done. Right. Yeah. So that's it. And thank you. And you can just you can also like, I can just end the session, and you can also like actually work with your hardware wallet directly. So you don't have like to move the coin from your hardware wallet at all, right? So there's some API that allows our website to connect to your wallet, to your hardware wallet. It's just similar to my Ether wallet, right? Yeah. Exactly. Yep. I mean, it's just similar to my Ether wallet, right? Yeah. Thank you. Yeah, only with the currency that we support. We support. Yeah. Right. So we have lined up, a few very strong partners in the last few months. So AppCoins is sitting over there, and we also have like Gipto, Wax, Storm Token, and Aditus. So one great thing about all these partners is that they have like millions of existing users, right? So when we launch, we expect that the traffic that our partners drive to Kyber Network is going to be terrific, right? So we can have like direct access to like millions of users. We also have like some strategic and and research-based partners. So one of them is blockchain at Berkeley, and the other one is Enigma. So this partner will help us, get better market view for the reserve operators, and they also help us deciding the how to have a pricing strategy, and the rebalancing strategy for our reserve. So the main goal is to prevent our reserve from being depleted, and we can also offer more competitive price to our users. So what are the main applications of on-chain decentralized chains like Kyber Network? So one obvious application is instant exchange that I just demo with you, right? So if you trade with other normal exchange, what you normally have to do is you first have to send a transaction to deposit the coin to the exchange, and you need to wait for maybe like 30 blocks for the confirmation, right? And only after that you will be able to trade, and then you have to withdraw from the exchange wallet back to your wallet, right? But with Kyber Network, you can do everything within one single transaction, right? You can deposit your coin. You can Kyber will find the best rate, execute the trade, and return the coin back to you. So everything is done within like 12 or 14 transactions, 14 seconds, right? You have to pay for the gas, right? And we can also allow you to do some sort of proxy payment. So if you want to pay some merchants, and the merchant only accept Ether, right? And you have only maybe Omisego or the ZixDAO token, then you can send the token to Kyber. Kyber can do the conversion in the background and forward the payment to the merchants, right? And because we run everything on chain, so it is really easy to integrate with other dApps or other smart contract. So these are the main dApps or project in our ecosystem, right? And we are going to have a lot more. As more people raise capital through ICO or token generation or stuff like that, we are going to see thousands of coins and different tokens, right? And in many of these projects, if you want to use the app, right, you need to acquire the token. And it's even harder if this app talks to some other app, and these other app they also require new token, right? So is the user going to need to acquire thousands of different tokens if they want to work in this ecosystem? So with Kyber Network, they do not need to have any token at all, right? They can just buy token from Kyber on the fly. So they can just buy token A from Kyber and send the token A to the app in the same transaction, and the app can buy other token B from Kyber as well, and send token B to some other app, right? Everything happens within one single transaction. right? So here is one simple example that you know how complicated application like Melonpot it is a decentralized fund management platform can integrate with Kyber, right? So Melonpot allows everyone to contribute their coin and token to some decentralized fund, and they can get like dividend or profit or whatever from the fund, right? And if you know that you are going to get some Ether or some Omisigo in the next 3 days, right? And you see that the rate of Ether is super high today, and you want to sell all your future Ethers, what do? So you can like have a forward contract with Kyber, and Kyber can talk to the Melonpot contract, and we will do the settlement in 3 days, and we can offer you the price today, right? So this is and you do not need to trust like Melonpot or Kyber at all, right? Everything is done on the smart contract. So with all that amazing applications, are we done yet? Is Kyber the solution for everything yet? We are far from that, right? So if we look at the trading volume on for this is like for the status token and Ether. And we can see that Ether Delta is the only decentralized candidate here, and they process like less than 1% of the trading volume. So we still have a long way to bring decentralized changes to our crypto users. So the main reason is that the liquidity is low because most decentralized changes are really hard to use. They are built for crypto users, not for mainstream users, right? And right, so there's the trade-off between like centralized changes and decentralized changes. Decentralized changes is well known for being secure and also trustless, but they are really hard for user to use. So with Kyber, we want like to bridge the gap between usability and security, and we hope that we can offer the best solution to our crypto users and also mainstream users. With that, I want to conclude my presentation, and I'm happy to take questions. Yep. I mean, we are not against like 0x, right? So the thing about 0x is that they have the off-chain component, right? And I think it's great because they have like the order book, so that's why they need the off-chain order book. But it's not. First of all, it's not like compatible with all the decentralized apps, right? Like the example that I just showed you, like is like there's no way for the contract like to talk to 0x directly, right? So there's no on-chain order book, right? So that's why you cannot like know like what is the rate and stuff like that, right? And also like it cannot support like instant trade like what we do, right? Because you need like confirmation, you need like to send transaction and stuff like that. Yeah. Can you speak louder? Oh yeah, so for Bangkok, I don't think they claim they are an exchange anymore, right? I mean, yeah, they have some different name, but Bangkok they have the automated pricing discovery or something, right? Which they use some like I think they use some formula in the World War II or something like that, right? I think it's not practical at all, right? Because I think the price must be dependent on the market view, right? On the market demand, and that's why we have so the price in Kyber is decided by the reserve operator, and they collect like all the market view from different exchanges from the market, and they decide the price, and they send the transaction to the contract to feed the price to the platform. Yep. Yep. Yes. Right. So we charge like transaction fee, but not from the users. We charge from the reserve, right? Because the reserve are going to make profit, and we just like take some fees from every transaction that they serve. It's gonna be small because like we do not have any servers or anything, right? So it can be like really small. Yeah.
So the cost of the exchange will be the gas plus
Just the gas, right? So the users, they do not pay any transaction fee. They only pay for the gas, right? Right. Awesome. If there's no other questions, thank you. And I'll be around. So if you have any other question, after this, just talk to me. Thank you.
So let's move it to our next sponsor session, Coinbase. Let's welcome Coinbase.
好，大家好，我们是 Coinbase 哦。那 Coinbase 是一个交易所哦。那我们主要有2个 business model 哦。第一个 model 是我们成为一个加密货币的交易平台哦。然后这交易平台我们标榜的与其他交易所不同的创新，主要来自于2个。第一个就是我们是提供零交易手续费哦，不管是 maker 或 taker。 然后同时我们会提供这个高频交易的 API 哦，我们有高速的撮合引擎。然后第2个商业模式会是我们会提供 ICO underwriting 的服务哦，也就是说 ICO 我们会来帮忙做 ICO 承销，因为当在新创事业从募资的方式从 IPO 移转到了 ICO 之后，它会面临到几个问题。第一个问题就是货币的流通性，我把 Initial coin offering， 我把 coin 发出去之后，流通性问题怎么解决？因为流通性同时也会带来货币的增长哦。第2个问题就是它如何推广到市场哦。那我们会提供一个 Coinbase 是一个它推广产品、推广项目的一个渠道。再来就是我们希望打造Coinbase 成为一个能被大家所受信任的一个平台，这是第2个商业模式哦。 那我们的愿景是什么？哦，我们愿景其实就是希望透过加密货币来形塑未来的经济，哦，这是我们公司的愿景。哦，那先来看一下我们过去从公司8月1号成立之后，我们完成了哪些任务？哦，第一个就是我们从9月13号开始做 ICO， 在1个月的时间，我们募到了46000颗 Ether。 哦，相对于就是1800万美金，哦，那再来在11月14号，我们开启了交易所的 Open Beta， 哦，那最近发生的事情是在11月22号，抱歉上面打错，11月22号我们完成了第1个 ICO 承销的案子 Cyber Miles， 哦，我们帮他拿到了84000个 Ether， 哦，相对于台币美金3400万，哦，那给大家看一下 我们交易所的这个画面，这是 Open Beta 的一个萤幕截图，哦， 那我们预计是在12月18号会正式上线。我们全部跟其他交易平台不一样的是，我们全部为了有更好的性能以及更友善的体验，所有的程式码都是从无到有重新写的。然后 CyberMouse 在48小时之内，我们帮他们募集到了84000个 Ether。这在现在这种熊市以及越来越多的 ICO 的情况下是非常难得的是我们认为一个不错的成绩。那我们的 roadmap 是什么？现在我们还是处于前2个阶段就是我们要先做一个中心化的交易所，就像我们 ICO 里面承诺大家的第2个就是我们希望能做 underwriting 的 service， 因为我们相信虚拟货币会去形塑未来经济，所以我们因此相信 IPO 会逐渐的透过过去 IPO 的募资方式，会逐渐的透过 ICO 来完成所以我们就需要更严谨的滴滴我们就需要更严谨的 smart contract auditing然后需要帮他们做推广，甚至需要帮他们解决货币流通性的问题第3个就是我们 Robinhood 会是遵守各地的法规，所以我们会在各地去拿交易所的牌照就地合规一切以合法为前提。然后接下来第4步呢，我们会一样按照我们的 vision 去走。我们认为现在的区块链钱包远远的还没办法普及到所有人。原因是什么？原因是因为门槛太高了你要用钱包，你必须先懂得什么是公钥，什么是私钥那你要知道你的私钥丢了，你的钱就可能全部不见了最近有一个消息，就是一个交易所他把所有人的私钥都拿走然后把钱都转走了这就是比较没有良心的交易所，因为它托管了使用者的私钥那我们认为我们要透过 Wallet Service 来降低整个使用门槛你再也不需要去区分什么是 ETC 什么钱包，什么是 BTC 钱包那普及之后，我们希望它可以成为一个payment gateway， 我们希望未来的支付行为都发生在加密货币的钱包然后同时因为 ICO 我们会经营自己的自媒体就像是 Ether News 一样，我们会带给大家最新最热以及最完整的 ICO 评论还有产业消息接着中心化其实带来，中心化虽然可以提供很快速友善的使用体验，但是它始终没办法做到区块链的精神，就是公平、公正、公开所以我们接着要做的事情就是把exchange 往去中心化去移动我们会让人与人之间、点对点之间就可以直接完成一个 atomic trading这个交易是原子化的，它是不可分割，不需要第三方那我们就需要一个 interchain 的技术需要能做 cross chain transaction那这个链基本上我们就需要结合各行各业成为一个联盟我们会成立一个 foundation 来让我们的区块链技术在各行各业遍地开花我们相信现在是 Internet， 未来是 Interchain那在 Interchain Foundation 成立之后，我们希望台湾就由衷的希望，因为台湾已经错过了太多次的浪潮，我们希望台湾能再次，这个图是我非常喜欢的一张图，我们希望台湾能再次成为世界的中心，让世界再次看到台湾希望台湾能成为一个亚太的数位金融中心，或者是世界的区块链研发圣地那 Robinhood 的公司文化，我们秉持了这4个企业文化因为我们是做金流，我们要获取客户的信任，所以integrity 是我们第一优先考量我们认为所有员工的诚信是最重要的，不可以有监守自盗的情况发生，也不可以有交易所说都是骇客把我的钱偷走了这种不负责任的话再来就是我们组织很扁平，大家互相尊重各自的专业我们希望大家都可以在各自的领域 透过同样的这个平台，我们赋予大家发挥的空间，与公司一起成长，就是后面的 enable 跟过。我们从8月1号到现在已经是40个员工哦，那成长得非常快速。这是我们目前的团队哦，所有在我们官方网页上面都可以看得到哦。那再来就是一些我们的这个工作照与生活照啊，我们这个开庆功宴的时候啊，还有那个我们的这个策略长啊，应该说策略顾问 Tony Scott 从美国来台湾，我们拍的合照。那今天我们来了非常多人哦，那包含从前端、后端，然后包含 BD 跟 PM 啊，以及 HR 都在这里啊。那我们就在外面的摊位，那随时大家有任何问题都可以来提问跟交流。好，那在最后再给大家复习一下我们的 roadmap 啊 ，centralize wallet decentralize 啊 blockchain foundation 啊 the app center 啊，那最后一个我们希望加入我们一起来形塑未来。好，谢谢大家。
Hello, let's welcome our next sponsor, Brian from Infinite Chain.
I think there is some issue here, so sorry for that. I see, okay. Oh. Okay. So, hi everyone. My name is Brian. I'm a bit little nervous, so if there is something wrong, and don't judge me, okay? So, okay. So we are Infinite Chain. Today I'm going to introduce our product. So what is Infinite Chain exactly? Infinite Chain is a bridging solution of connecting blockchain and centralized system. So it is made up of 3 main topics: hierarchy-based multiple chain, distributed auditing, and index Merkle tree. In the next few slides, I will explain each of these. So first, what is hierarchy-based multiple chain? So we all know scalability is a key challenge of the blockchain. So we have to find a way to fix this problem. So we want to use a hierarchy-based multiple chain to solve this problem. It means we put all the transactions to the sidechain, and with that centralized system to generate this, use this transaction to build an index Merkle tree and put the root hash to the main chain. So we increase the throughput on the sidechain and reach the consensus on the main chain. And it also fits different centralized organizations, such like bank or corporation, can build their own sidechain with their business logic. For example, a streaming service, they can store the length of a user's watching time. Or on the other hand, like payment service, they may want to store each installment period. So here is a simple animation for illustrating the relationship between the sidechain and the main chain. So you can see each business logic, like logistic or financial service, they can host their own sidechain and then generate a unique root hash and put it in the main chain. Okay, so second, what is distributed auditing? So after the sidechain generate a hash value and send it to the main chain, there's no way to make sure the consistency between them, right? So we want to find a way to solve this problem. So after we use the distributed auditing to solve this issue. After the agent to send the root hash to the main chain, user should audit his own transaction. So when user find there's something wrong about his transaction, then he can solve it by take the objection on the main chain. And actually, this system is based on an IEEE paper 2016. You can find it on Google. So Professor Huang published this paper last year and applied the pattern this year. So it provides a solid solution for fraud proving. So here's another illustration to explain how this auditing process works. So you can see first, user will send a transaction to the agent, right? And then after a while, the settle time is up, the agent will collect all the transaction and send it to the auditing node. And auditing node will use the index Merkle tree algorithm, which I will introduce later, and generate a unique root hash. And then send it to the blockchain. And step 4, you can see when user is going to audit his own transaction, he will ask for the auditing node for a slice for his transaction, a slice of his transaction, sorry. And then calculate the root hash of slice. And he can compare the root hash and the root hash on the blockchain. If they are equal, the auditing process is done. And if they are not equal, then you can take the objection from the judgment on the blockchain, which right now we use the smart contract to do it. Okay, so third topic is index Merkle tree. So since we got a lot of transactions in this Merkle tree, right? So it will cost a lot of time to search a specific transaction because we have to audit his own transaction. So we want to speed up this process. We put the Merkle tree in an array structure, and in that way, you can find a specific hash value by the index. And you can use the formula here and calculate the index. Not only everyone can get the same index, but the most important is if you want to check a specific transaction, you can know it is existing or not immediately. Okay, so why infinite chain? So first, performance. We increase TPS and reduce the data volume by the hierarchy-based multiple chain. And second, security. We also keep a cross-chain consistent by distributed auditing and use asymmetric cryptography to keep the data security. And last, accessibility. Every centralized organization can enable their service on the blockchain easily by our SDK. Here is a simple comparison between public chain, private chain, and multiple chain. So multiple chain can take the benefit of public chain, such like public consensus or global security, and also the benefit of private chain, such like saving storage, privacy, or even better throughput. Okay, here is another comparison between different types of multiple chain. Channel-based, relay-based, and hierarchy-based. So hierarchy-based multiple chain can solve the problem the previous two types didn't actually focus on. So we want to provide a solid solution for increase the throughput and also consistent between the main chain and side chain. So here is a roadmap. So we just finished our first demo version system. And now we are going to cooperate with our partner for our first application. And now our team is going to develop the SDK and GUI. So Infinite Chain wants to be a bridge between the centralized system and blockchain so that every large-scale bank or corporation or government can use our technology and this transaction can be supervised by them. Okay, so I think it's all. If anyone got any question, our booth is outside and we can talk about more detail. Thank you.
Let's welcome our next sponsor, Armies.
Hi， 大家好，我们是阿密团队，然后非常开心，就是台北 Ethereum 给我们这个机会来这里介绍阿密这间公司。然后因为现场来了很多国外的来宾，所以接下来的报告我们会用英文的方式进行。这样，好，Good afternoon, everyone. I'm Mark. I'm very glad to be here to introduce Ami. To get started, I want to give a short background about Ami and what we are doing now. Ami is a blockchain service company based in Taiwan. We provide services including blockchain infrastructure, application, as well as research. Our most known project is distributed ledger for cross-bank transactions in Taiwan. So in current existing financial world, without exceptions, all financial systems looks like the topology below. There is a centralized database to keep track our accounts. Blockchain-based ledger looks like the topology above. By using it, transaction cannot be altered once validated by consensus and written to a ledger. So it can reduce costs, time, and risks. So our first task is to bridge the financial system and the blockchain. And over time, we want to bring the whole financial system into the peer-to-peer world. After some studies, we choose Ethereum as our blockchain. It's not only because we can write our own logic into smart contract, but also Ethereum has the most powerful and active developer community. But the current POW consensus cannot meet our own requirements in our project, so that's why we implement Istanbul BFT. Istanbul BFT or IBFT is inspired by Kostrov-Liskov Practical Byzantine Fault Tolerance (PBFT) paper, which is published in 1999. With our implementation, they have the following key features. First, all block in IBFT is final. It means no fork is possible and no confirmation is needed. Second, we have manageable validator set. So validators can be added or removed by voting. And on performance side, it can process about 800 transactions per second. We have the same node scalability as POW does. And all block in IBFT is self-verifiable. We put our consensus proof into block headers. So supporting light client will be very easy. And finally, we have gossip network, so we don't need strong connections. The current status of IBFT is we've filed a pull request to Go Ethereum. So please check out our EIP 650. Again, 650. Okay, and the IBFT now is merged in Quorum. After distributed ledger project, we also developed other debt projects like fitness and food records. And this project shared the similar architecture in Ami. With this experience, we can provide blockchain as a service to help developers to create their dApp quickly. So it's our ongoing project now. In our goal, developers can set their desirable blockchain consensus and configuration, and we can help them to build up the backend. After that, developers can use our backend to create their dApp quickly. During we develop our blockchain as a service, we found we need more tools to build dApp quickly and build up our platform or more automatically. I mean, it gets a lot of help from community, so we decided to contribute our knowledge back. So we open source our tools and hope more and more developers can use it and give us some feedbacks. We want to hear your voice and make our tools more powerful and make our community stronger. The first tool is ETH-Client. There are 2 RPC clients in Go Ethereum. Now, developers need to keep 2 client instances to communicate with Ethereum because they are support different functions. So to simplify this, we wrap these 2 clients into our ETH-Client. So developer, if you use our ETH-Client, they only keep 1 ETH-Client instance, and they can use all the functions. I think it's a very useful utility. For the second one, we propose a new dApp architecture. The figure here is the traditional dApp architecture. Client can communicate with contracts through the server, but there are some weaknesses in this architecture. For the first, there is no interface defined between client and the servers. It means it's hard to work cross-platform and language. Second, server just passed the client's request to contract. For example, if clients want to get name from the contract, the server just finds the corresponding API to get the result and return the result to the client. We think this kind of code is very boring. So here is our solutions. For the first issue, we can have a portal to define the interface between client and the server. And the communication between client and the server can be through gRPC. So we provide a tool, so2portal, to generate the portal file automatically. For the second one, we can use Go binding and generate the portal file to generate the server code automatically for you. This tool is gRPC contract. So here is our proposed dApp development flow. All you need to do is write the contract code. And after that, we can take the rest for you. So first, after you wrote your contract code, you can use sock to get your bin and the API file. And after that, you can use Abigail to get Go binding, and then you can use so2portal to get your portal file from the API file. And after that, you can use gRPC contract to get the server code from the Go binding and the portal file. And after that done, you build a dApp architecture. Okay, to sum up, AMI is a blockchain service company. We like to sharing, to discussing with developer and the communities. If you want to find out more technical details, please visit our website, our GitHub, our Medium, or contact us directly. Our team is there. Hey, please raise your hand. Yeah, so if you have any question, you can ask them, okay? Thank you.
喂 ，OK， 那现在又进到我们的休息时间了。对，那我们下一个议程是预计3点半开始。对。 好，所以3点半我们在这边回来，大家见。对。
Resume in 3 minutes. We'll resume in 3 minutes. Let's resume. Let's welcome our next speaker, Thomas Greco. He will share with us on OMG, Open Financial System, Open Financial Networks. Thomas, is he here? Do we have another Thomas substitution here? We will all remember Thomas for this. I guess I might as well just Thomas! You will be remembered.
Hi, I'm Thomas Greco, and I'm a special advisor for Omise Go, which is a project in the Ethereum space. So I'm here to talk about the value of open financial networks. And I see that I'm 5 minutes late. Very sorry. So maybe something to think about is, why was crypto invented in the first place? And it was a form of money. Bitcoin, 2008, almost 2009. White paper looked like we had a way to solve the double spending problem. Now we don't need a central authority to make money that people can pay each other. And it is cheap, and it is efficient, and you should be able to buy a cup of coffee with it. And why was this type of thing invented? Well, shortly after the global financial crisis in 2008, it was a very opportune time. We saw that money had many, many problems. These problems, of course, were already known, but it was a topic of big conversation. So let's talk about the bugs in money that we have today. Today, when we use money, we have very few choices about which kind of money that we can use. Usually we are restricted to our geography. We are restricted by the types of money that the people that we want to use money with, because money is a social experience. We're restricted by the kinds of money that they want to use. Sometimes due to complex reasons, sometimes there are political reasons. Some currencies are not available. Some currencies are explicitly unavailable. Currencies like Bitcoin, for example, are banned in places like Bolivia, Bangladesh. I believe Venezuela is now on that list. And of course, you are not supposed to take foreign currencies in certain countries as the medium of exchange. So this is actually a very common thing, and we all just take it for granted that, well, we're in country A, of course we should not be using country B's money to settle debts or pay for goods or services in country A. Users cannot easily move funds for a variety of reasons. Oops. With money systems, electronic money systems that we have today, because everything flows through financial institutions or intermediaries of some sort, there is always the risk that a transaction will be reversed. Of course, given that transactions can be reversed, and there is a cost to this, the cost of doing the administration, the cost of perhaps insurance in certain cases. Monetary systems that are reversible also have a cost. That risk has a cost, and you see this cost in very clearly in payment authorization schemes like Visa MasterCard, where the costs to Visa MasterCard begin at approximately 2%. So that's quite a lot for every transaction. You have to be concerned that due to fraud or something that is unacceptable to someone somewhere, there has to be a cost to everyone. And because there is this cost, there is also the cost to the individual to help pay. Individuals must front the cost of showing the intermediaries that we are trustworthy people. We are people that have a good reputation. We are people that, in the future have not expressed unpopular opinions, so that our credit score, because eventually some of us in some countries will end up having citizen credit score type mechanisms that may affect our ability to use money. We already have this when our financial credit score, our past history of how we use money, shows that we have not always paid our debts, for example, then certain forms of money that are based on credit are no longer available to us. Or if we were too poor to have that credit to begin with, then they were never available to us in the first place. And you can see, not just on an individual level, you can see how actually this is on entire societal levels. In the last few years, it's been increasingly concerning how banks that are basically being forced to de-risk individuals and companies in often the most hard affected economies are also the most vulnerable ones. It's quite a serious issue in banking, international banking at the moment. Transactions are expensive. Often the reason in current monetary transfer systems they're expensive is because, well, they can be. The people in the middle are in a position to charge within reason whatever they want. And then, of course, the big problem that was very widely discussed in 2008 and the years following is that money issuers, namely governments, can change monetary policy, monetary supply at will for any number of reasons. So Bitcoin was invented, and the idea is that, well, is not Bitcoin going to solve this problem? And it turns out that despite Bitcoin, having been much more adopted than in the past years before, Bitcoin is not so easy to use as a form of money. It's a little bit not so good UX, and also your friends and neighbors don't use it. So then, like they want to use the money that the governments issue, and of course, who can blame them? The value of Bitcoin is also up and down too much, and even if it's up and up, it's still a problem because if something is going up in value, you don't want to spend it. So catch-22 there. Another thing is that money by governments also has value. Economically, governments take care of people. They're the lender of last resort in a time of national crisis, group crisis, some kind of natural disaster, epidemic, disease, warfare. If there is a very, very big social problem, the government is the people that pretty much everybody, including people who maybe don't like having too much government, expect will take charge. So we should not let criticism of government abuse of power make us blind to the fact that in a responsible society, government also plays a role. This may involve government involvement in monetary supply. So then the question is, what can be done? And one proposed answer is maybe Ethereum can do something. So why Ethereum? We'll get into the specifics in a little bit, but I propose that we can use Ethereum to continue Bitcoin's goal to make a peer-to-peer electronic cash system. So Bitcoin's goal is not that new, but the idea is that it can be a kind of like money without borders, or money without restrictions, money without costs, money without barriers, not just national borders. That's not the implication. And before Bitcoin, actually Ripple is older than Bitcoin. Ripple's idea was to also have kind of peer-to-peer money, since before it was a blockchain project. I think 2006 was when it started. Before Ripple, there was also the original PayPal vision from 1999, if I remember. The idea is that we should have this kind of peer-to-peer money. And finally, decades-long desire took very, very clear form with Bitcoin. But we think that maybe Bitcoin has difficulties, and we can help Bitcoin overcome some of these difficulties with Ethereum. We can do what Bitcoin set out to do, which is make a non-reversible, cheap-to-use, and reputation-free kind of money system. Also, it can be more accessible than just Bitcoin alone. It can be something which is accepted by your friends and neighbors already, and possibly as stable as government money, maybe even more so. Asterisk, that means ask me about it later if I forget to talk about it at the end. So how do we do this? Essentially, in concept, we do this by putting together existing currencies into a competitive and fair environment, and making that environment freely available to all people. What is OMG? Okay, it's an original decentralized exchange designed for Plasma, which is a smart contract scaling solution meant to be used on top of Ethereum, or actually any other smart contract enabled blockchain. The OMG network is a 100% public, permissionless, fully on-chain, cross-chain compatible, currency agnostic, massively scalable, decentralized exchange that can enable free trade among fiat currencies and network-backed currencies, and can serve as a single point of execution for the entire world's trading needs. And by trading, we don't just mean trade Bitcoin for Ether. Right? By trading, we mean trade some unit of account for a bowl of noodles. So breaking that down, what does it mean, this long list? 100% public permissionless means that by being a public something, it should reflect the will of whatever the thing's constituents are, in this case, people. It should not be easily gated by any company or state or special interest. It should remain permissionless. You do not have to ask someone's permission to use this. Bitcoin is, for example, a permissionless network. Ethereum is, for example, a permissionless network. By contrast, Ripple is not a permissionless network. It is fully on-chain. It means that there is a high level of certainty that things are executing correctly and being remembered correctly. That is the advantage of putting something on a blockchain by using massively replicated ledger construction. It is very difficult to find some mistake or make some mistake and find some mistake has happened. Cross-chain compatible means that this decentralized exchange that runs essentially connected to Ethereum will also be able to talk to other blockchains, other ledgers, including the efforts that are being made in those directions, and able to then therefore leverage the resources and stores of value that are contained on all these other amazing blockchains, and we have hundreds of them. Massively scalable means that it can be useful for more than just a small subset of technology-oriented people that are interested in trading cryptocurrencies, because Plasma can theoretically go up to billions of transactions per second. You can use this for, honestly, nothing really needs billions of transactions per second. You can pretty much take care of every hand-to-hand cash transaction in the world simultaneously and under 1 million transactions per second. The idea, though, is that by bringing fiat and crypto together and enabling free trade between them or among them, users will have the power to choose what currencies they want to use, whether it is the currency of the country that they happen to be in, or the currency of the neighboring country, or even currencies that are not issued by nation-state level actors, such as decentralized currencies that are issued by thousands of people who don't know each other, who are nevertheless working together to run a network. So the idea basically is that in practice, what this should look like is that anyone who has a smartphone and has some kind of digital money capability should be able to trade the money that they're using for any other money with anybody else's, without anyone's permission, at the drop of a hat. This essentially gives a farmer in Bhutan kind of the same financial freedom, financial sovereignty as a high-level banking executive has today. And of course, this farmer in Bhutan may think, I'm going to India next week. I don't have time to go to the Forex place because I live on the border. And if I trade money on the other side, I could lose a few percent. Why don't I just do it on my phone right now? Now I have rupee, and I don't have to worry about the fluctuation because so many countries, hyperinflation is an issue. This could also give users, normal people, a way to not have to be particularly well connected or well educated or resourced to be able to nevertheless find some kind of protection against macroeconomic policy that not only do they agree or not disagree with, they may have no knowledge of at all. We cannot expect people to participate at all levels of government at all times and all topics. That's just not a realistic form of democracy. So yeah, fiat and crypto, we bring them all together. And this decentralized exchange can serve as a single point of execution for the whole world, trading and money transfer needs. What I was saying just now about people's everyday money uses, this type of construction is meant to be a rails for all of them. So the question is, well, what will drive adoption of this new kind of value transfer system? Because you can propose all sorts of interesting constructions and, based on all sorts of economic or monetary theories, but ultimately, they have to be connected to like an ongoing real world of existing use cases and the people that participate in them. And the proposal is that there is actually a digital money pain point that is becoming very, very apparent over the last few years, essentially, particularly in developing nation countries or countries that have not, for whatever reason, adopted debt-based online or debt-based electronic money systems, like credit cards. We find that online money with good infrastructure is primarily debt-based, and that most people are simply not credit-worthy. Sad but true. Asset-based online money, on the other hand, have bad infrastructure, even though, of course, everyone is good to give digital wallets to, because they have to pay for them before you give it to them. So the idea is that such a network as the OMG network could possibly incentivize digital wallet implementations to connect to the same ledger. And on the other side of the consumer-merchant relationship, it is also possible to incentivize e-commerce payment gateways to take digital money. Incentivize is an unnecessarily strong word. They already want to. The problem is just the overhead. And what overhead? The problem is that existing wallet and payment systems, they are very highly siloed. They are broken up and kept away from each other, and they depend on traditional financial infrastructure. Any given user who wants to use a particular company or bank's or telco's digital wallet, like issuer A, has difficulty interoperating with a corresponding company or telco or bank's digital wallet B, And essentially, I mean, there are many, many kind of proximate causes for this, but you can all trace them back to the same root cause, which is that there is some centralized network or another that all these wallets are running through as the rails. And usually they are not owned by the wallet provider. They are somebody else's centralized network. And for this reason, digital money adoption is quite low, with the exception of China. Won't go into that just now, but we can see that obviously it can work very well if there is the will of some sort to make things like Alipay and WeChat Pay extremely dominant. Meanwhile, for the rest of the world, it is quite expensive for payment wallet providers to adopt these systems and to really get them into full use. And then it also bears other risks, which are more like banking compliance related. So the question is, why put up with it? And the answer is because we have to put up with it. Without sufficient coordination, we end up being beholden to privately owned payment networks, which are kind of just a monopoly or oligopoly of entrenched interests. They charge a lot. They're kind of unpleasant to deal with from the perspective of fintech companies or financial service companies that have to work with them. And these networks are very resistant to improvements that don't first improve the conditions for the people that have power in the network. So we break it down really quickly. Privately owned centralized networks are not so convenient for a number of reasons. Probably the most important is it puts users kind of far down, and for that reason users don't respond well, and because users don't respond well, there's essentially no network effect. They're actually quite vulnerable as well. There are many risks to both users and the payment providers. Things can go wrong. And too many of these systems have a setup where very few people are making decisions. And you know what happens? You have this principal agent problem. You have people who are tasked with making decisions on behalf of many people who then just end up making decisions on behalf of themselves. So that was that slide. So we have limited consequences for bad actors. We have cats that are sheltered by... yeah. Hello, Gremlin. It's a cat named Gremlin. This is not a situation that most players in the fintech and financial services space actually like. Most payment providers and digital wallet providers do not want to do this. And fortunately, very soon, we should be able to do better. We can replace this with this. Same old boring slide. With this. Do you guys know about this? Yeah, it's a plasma joke. Yeah, it's basically, ooh, a little bit dropped. That says Ethereum under there. It says root chain Ethereum. But the idea is that with a plasma construction, you are able to launch networks, either a public network or a private network or a combination of public and then small private networks on the public network on top of what is called a root network or a root chain. And you essentially isolate the economics of the stuff on top from the stuff on the bottom. And you feel free to take a picture. I won't go through that. I only have 5 minutes. But if something goes wrong, you can just withdraw. The way that the network ends up, the proposal for OMG network ends up being a public network is by making it a proof-of-stake network that runs on Ethereum, but is isolated from Ethereum's economics by having its own token. That people basically buy and run and the network with, and like Bitcoin or like Ether, there is no kind of permission requirement to participate in running the network. The way that OMG works is like slasher style. You know, you put a deposit down for the staking, And if you, as the validator, misbehave, then you get your money taken away. And if you behave well, then you get a little bit of money, and it drives the network, and it drives the economic incentive to participate in making the network run. What this does is it allows us to run a network that has no central self-interested authority. Because it is a permissionless system, there is no gatekeeper. The transaction fees are much, much lower than Visa, MasterCard, like a fraction of it, because there is no cost of insurance that is necessary, and there is no cost of rent being paid to our oligopolistic overlords. The transaction costs reflect the cost of validation. Essentially, it is the cost of operation that is paid to the community, and people who run these things, they have to eat too, and capital has to earn money, so there is some cost, right? That's reality. Lock the network open, and everyone wins. Corey Doctorow, actually, lock the network open. Thank you, Corey. So I think everyone knows what this is, but yeah, take a picture if you don't. And OmiseGo is a subsidiary of a multinational payments company in Asia Pacific called Omise that has been very heavily interested in participating in Ethereum research and development and funding since 2015. And basically, after about a year and a half of research, thought that this was the best way forward for their business and for what they want to do with their time in the world. The question is, why is there a private company building a public network that they will not own? Because, as mentioned, the OMG network is a public network. Essentially because private network type constructions were examined, and none of them came even close to being as, how do you say, what's the English word for, no, like when something has potential and then there's just compelling. Yeah, the private networks were just not anywhere near as compelling in every single way. It just, the only thing that maybe it looked more interesting was that it was more safe, but that's like, who wants that? A decentralized network runs competitively, does not charge much more than the cost of maintenance, resists rent extraction mechanisms, and can also be iterated upon, improved by the users. So Omise recognized the need that this infrastructure should exist, so no one had built it yet. And that's really just basically it. I feel that having kind of insight into what makes the crypto movement special would give someone insight into why just make public infrastructure instead.
Let's welcome our next speaker, Vlad Zamfir. Are we having the situation again? Mr. Zamfir? I'm not doing the joke again. Okay. Mr. Zamfir will talk to us about blockchain governance. So let's welcome Mr. Zamfir.
Hey everyone. Ooh, this is super loud. Bear with me while I plug in, and then we'll be off to the races. Yeah, I can do it. Do you guys see anything behind me? With the table. Oh, there we go. Almost. Yay. Great. Hey, everyone. Thanks for having me. I'm excited to talk about blockchain governance. It's not often that people invite me to talk about anything that isn't tech. But this is a topic that I'm pretty excited about. And I've given a lot of thought to, especially in the last like 4 to 6 months. So I'm going to share what I can, and let's get going. So basically, here's the kind of table of contents of my talk. So I'm going to talk first about like, what is blockchain governance? Like, why do we care? And then give a basic language for governance generally, and then to think about Ethereum governance in specifically, and I'll give in detail a kind of account of how Ethereum governance works. And then I'll talk about like, what is it? Is it legit? Like, is it legitimate? Like, is Ethereum governance something we should be happy with? Or, and then I'm going to have basically like a conclusion without many recommendations, but hopefully by the end of the talk you'll understand more about governance. So what is blockchain governance? Well, fundamentally, blockchain governance are about two things. There's like nodes on a network, and there's like software that those nodes run, right? And these software, every blockchain is going to have these two different components. There's going to be node operators who have to decide to run software, and there has to be software repositories that are governed by like some software development process. So we need blockchain governance for technical upgrades, even just for maintenance. There might be bugs, there might be DOS vulnerabilities, there may need to be changes to the repo to prevent bit rot, to make things performant over time, right? And there might actually be the need to use governance to recover from an attack, right? If there's a 51% attack and a whole bunch of blocks are reverted, if there is a consensus failure where nodes can irreconcilably can't come back to consensus, blockchain governance can be important, right? Because if blockchain governance refers to these decisions, at least we know so far, about what software node operators run on their nodes, and on what code actually ends up in the repos. And so for recovery from attack, we're going to want actually software to end up on nodes that fixes the problem. And there's also this whole idea that like governance is the way that we're going to make sure that the blockchain works for society. That like it needs to be kind of it's like a technology that is used by some like community, and ideally a global community. And so and blockchain governance represents a kind of last line of defense for mitigating harms and making sure that the blockchain governance is actually a good thing, or that the blockchain is actually has a good impact on the world. And we're going to talk more later after we talk about governance in general about like what it means for a blockchain process to be good in some way. So part 2 is going to be basically a glossary of terms. I'm going to go through a whole bunch of different terms which should be useful, or I'm promising you will be useful for talking about governance. It's kind of long. It's going to be, I think, most of my talk. So you know, bear through it because it's totally going to be worth it, and all these terms should be useful for you and thinking about governance, not just in the blockchain space, but more generally. So all governance processes, basically, they make decisions, right? Governance processes are fundamentally about making decisions on some kind of resource that's being governed, and I refer to that resource as like the governance process is like this thing. It basically mediates between participants who make decisions, who interact with the governance process so that the process will eventually make a decision, right? So the government's decisions are going to be a function of the participation of these groups of people called participants. And there are these things called stakeholders. Stakeholders are agents who are affected by the governance decisions. Governance processes have structure. The structure is kind of defined as the thing that mediates between the behavior of the participants and the decisions. You know, the participants are going to somehow do something in the governance process, and then that's going to lead to decision A or maybe decision B if they have different type of participation, right? If we're governing a bank account together and we have like a policy that says like 2 of us need to agree on a transfer of funds, you know, there's going to be structure in there that basically like says that like, okay, well, you know, actually checks that 2 of us have provided consent before moving funds. Maybe if we provide consent to move to that account instead of this one, it'll lead to a different action. And those represent, you know, different mediations of participation to decisions, right? So you can think of this pretty much as the structure of like a function or the structure of a process. Different inputs, different outputs means it's a different function. Or sorry, the same inputs, different outputs means it's the same, it's a different function, and you can think of a function as like all of the ways that inputs are mapped to outputs. And so the similar way, the governance, the structure mediates participation and decisions. Participants have like information, and they use that to bear out their incentives, right? And their information will include things like what they know about the governed resource itself, what they know about the governance process, and also what they know about each other's states of knowledge and what they know about each other's incentives. And that's actually going to be quite interesting because, as we know from like, you know, a whole bunch of kind of like game theory research is that like knowledge of participants' relative states of knowledge, so like participants like players' participants of knowledge of each other can really affect the way that the game turns out, right? And so basically, they can have expectations, which are kind of like anticipations, that are kind of like socially enforced, right? And those can turn into governance norms, which are really they're kind of expectation that is broadly held and broadly enforced. And they can have common knowledge. Common knowledge is this really interesting state of knowledge where not only do I know that you know, and I know that you know that I know, and so on ad infinitum. And this kind of is an interesting thing because it lets people act as if something is a fact. Lets them take things for granted because there's no real deniability because you kind of know that everyone knows and you know that they all know. And so there's no way that like you can deny the fact that you know. Everyone will know that that's nonsense, right? And so common knowledge is really useful because and it's really powerful because it lets people enforce their expectations and norms without any fear of repercussion. Because not only do you know that you did something wrong, you know that everyone knows that you did something wrong, and so it's really hard to kind of fight back. And so this kind of information that participants have of each other can restrict and mediate the way that their participation actually impacts the governance outcomes. And so we can separate out governance structure into two parts, internal structure and external structure. Internal structure is the structure of the governance process that's kind of independent of the information and relative states of knowledge and mutual states of knowledge and the common culture of the participants. It's just kind of in the system. And then there's external governance structure, which includes things like governance norms, which do in fact seriously limit any participant's ability to influence decisions because if you behave in a way that isn't in compliance with governance norms, the other participants will essentially not let you have your way. So for example, if we have a governance process where the norm is that we only show up on Tuesdays and you show up on Wednesday and there's no one there, you're not going to be that effectual. And so the Tuesdays only structure, although it's not part of the internal structure, it is part of the governance structure because of the norm, because the norm isn't something that any one participant can change, right? So basically, and external structure ends up being really, really critical because, like I said, every individual's participation is mitigated by it or mediated by it, and also it's really hard to change external structure because everyone kind of expects it to be there, and if you try to convince people to use something else, or to violate some norm, they're going to have a hard time, right? Because because of the common knowledge makes it really difficult for them to be convinced that other people aren't going with it anymore. So basically, in terms of kind of a game theory thing, participants are players. The structure is the rules of the game, and the players might be playing, like, for example, a coordination game, and the external structure might, for example, restrict the possible coordinated choices equilibriums in the game, right? So in a normal coordination game, there might be a whole bunch of possible ways we coordinate to achieve an outcome. With an external norm, we might be able to rule out most of them and say, okay, we either choose that one or this one, dramatically simplifying and facilitating the governance process, but also adding a lot of structure to the game, right? Just with that external norm. So basically what I've said so far is, okay, there's participants, they have incentives and information, and there's a structure to the governance process that restricts the way that they can act to influence decisions. The structure can be formalized, which basically means that you can put it in a language, or you can describe it in a model, right? And that makes it really easy to communicate. It makes it easier for participants and stakeholders to know what's going on in the governance process. It can be institutionalized, which basically means that you could take this like formal thing or this model and encode it somehow into the structure of the governance process, either by making it a norm from a governance level, like an external, or by like encoding it internally in the governance structure, which will be possible if the internal structure allows for amendment. An institutionalized governance process, especially if it's formalized, can lead to a lot of procedural fairness. You can make it really, really fair. Everyone knows what this process is. Everyone knows how to participate. And you kind of just show up and participate. It's also somewhat risky, right? Because if you institutionalize something, it becomes much more sticky, right? There's this fixed formalization that everyone knows, and you can't change it without anyone noticing. And then and there's like an institution that's derived to, or that basically somehow encodes that formalization, and it becomes very sticky, right? And what if the institution sucks? I mean, this is a kind of common thing that happens in the world, right? People will come up with a formalization, they'll institutionalize it, they'll deploy it, they'll use it, and they'll find out years later that the institution kind of sucks and they can't change it. And so it's really risky, even though you can get a lot of procedural fairness out of formalized, institutionalized governance. So now we're going to talk about stakeholders and their relationships with the decisions made by governance processes. So stakeholders is called disenfranchised if and when a governance process makes a decision that isn't aligned with their interests. And they're called represented otherwise. Just language, right? And this is language that's going to be super useful, but I'm not going to say much more about that. Stakeholders apathetic if they could be participating, but they've given up. Could be because they perceive that no matter what they do, they'll be disenfranchised, or it could be for whatever reason, and we still call them kind of apathetic. If they're not apathetic, we call them engaged. A process is called illegitimate if for a group of stakeholders, if they have common knowledge that it disenfranchises them. So if you and all your friends know that the process sucks, then, and you know that each other know it, and you know that each other know it, and you kind of really have this, like you all regard it as a fact, then we call that governance process illegitimate to at least your group of stakeholders. And it's called legitimate otherwise. If a process is illegitimate, stakeholders have basically a few options. Not that many, not that surprising options. They can either stick around, be apathetic, and like loyal, and basically just continue to be disenfranchised. You know what I mean? Hopefully it'll stop. Hopefully one day it'll stop, and things will be better. There's persuasion, right? You can try to engage with people who are participating in the governance process and convince them that actually there's stuff they don't know, or their incentives aren't what they think they are, and try to impact their decisions. You can try to change the structure of the governance process, either by changing the internal or external structure. You can revolt, right? You can try to replace the process wholesale, and basically say like, okay, here's an alternative, or this process isn't legitimate. We're not going to use it anymore. Let's try to pick another one and use that. And then there's forking and splitting, which is similar to revolution, only it doesn't require that the original system be disposed of, or it doesn't require that it be replaced entirely, but you can just kind of, when it's possible anyways, make a copy or an alternative that has a fraction of the resources or a copy of the resources and governs them in parallel. And so basically these are kind of the options when you're being disenfranchised. And you and your friends all know it, and so can act together in a way that will hopefully change outcomes. But there are limits, right? There are limits to what you can do with persuasion, because people have incentives, and you can't really persuade them that something isn't in their incentive if they know better. There's also limits just to communication, right? Amendment may not actually be allowed by the governance process, right? Or by the structure internally, right? If there's no rules for how to change it internally, or if there's no norm externally that allows that, or maybe there might even be norms externally that prohibit it, then actually amendment might not be actually reasonable. Forking, when it's not always possible, because you can't always actually make a copy of the resource that's being governed, you can't always meaningfully split it without causing a lot of damage. But when it is possible, forking can be a lot easier than revolution, because you don't need to overthrow an existing system. You just kind of can create a parallel one and over time gain legitimacy, as opposed to kind of having to declare the original one legitimate and and get everyone to believe that the new one is legitimate without them even having any time to observe it. So revolution is risky. I mean, we kind of know that. And forking is kind of less risky, but it's usually not as available, at least like historically. If we look at a lot of use cases in governance, forking hasn't been often an option. And what it is, it's not really clean forking like it is in the blockchain, where we just have a copy, like a perfect copy of the thing that we were governing before. So basically, like, legitimacy is actually incredibly important for blockchain governance, or for any kind of governance process, right? Because it promotes engagement and it prevents apathy, revolution, and forking. We really, like, it's kind of a really high aim for a governance process to be legitimate, which is to say, for stakeholders to believe in common knowledge that that governance process represents their interests. So an ideal governance process then basically has a structure which itself guarantees that participation from the participants who have their information and bear out their incentives will make decisions, or will participate in the process in a way that it makes decisions that optimally preserve stakeholder interests and of all the stakeholders, and does it with sustainable legitimacy and procedural fairness. So this is basically the kind of this idealistic governance world where, you know, the structure itself guarantees that no matter what the incentives and information of the participants are, the decisions that are made are in line with all of the stakeholders. And it's also legitimate and fair. So this is an ideal, it's aspirational. It's not realistic for a number of reasons, including that often stakeholders have competing incentives. Often it's impossible to make good decisions even with lots of information, because of the computational resources and other limitations. It's also often hard to make a system that's legitimate, because the legitimacy is often it's a function of perception, and people's perception can be swayed by factors outside your control, right? It's also really hard sometimes to make procedurally fair systems, because procedural fairness is actually a vulnerability, right? It means that anyone potentially could come up and participate, even if they're adversaries of the stakeholders. So this is an aspirational ideal, but it somehow is what I think we all should aspire to in our blockchain governance processes, right? We want processes that guarantee that the participants produce outcomes that represent the interests of stakeholders, that, you know, are legitimate and fair. So here we go. Quickly over all these are the kind of key terms I want you to take away, right? Governance process, the governed participants and stakeholders, right? Participants have, like, you know, potentially common knowledge, expectations, and norms. Governance structure is both internal and external. Governance can be formalized, institutionalized, and that maybe will lead to more procedural fairness. Stakeholders can be disenfranchised, become apathetic, and that can mean, when it's in common knowledge, that the governance process is illegitimate. When things are legitimate, there's not that many options. You can basically continue to be loyal, or like kind of participate and be subject to the decisions of the legitimate system. You could try to persuade the participants to change their mind. You can try to change the system. You could try to, or you can revolt and fork. And then there's this idea of ideal governance, which is you know, perfectly, like, does what's in the stakeholders' interests and is legitimate and fair. Great. So we made it through part 2. That was like the hard part. That's where all the lingo comes out. Part 3, we're going to talk about Ethereum, the Ethereum blockchain itself. So I'm going to do my best to describe the structure of the process, and then I'm going to try to talk about the legitimacy of the process. So, structure first. So basically, people, you know, kind of assume that blockchain doesn't have structure just because it doesn't have a formal model. But actually, governance always kind of has structure, because it needs to at least have some very basic structure to make decisions. And basically, the governance process, it's important because the governance process, the structure of it, actually limits the participation, the power of the developers, essentially. And the Ethereum governance process is made up of a bunch of different interlocking governance processes, which is actually quite a common theme. And so I'm going to go over them and show how they fit together. So here are the ones that I'm going to go over. I'm going to go over basically these are different resources, and each of them have kind of a corresponding governance process. There's all the full nodes, various types, miners, there's the Geth codebase, the parity codebase, the altdevs call, the Ethereum improvement proposals, and the roadmap. There are other resources and other processes involved in Ethereum governance, but this is all that I'm going to cover. So full nodes, basically, there are operators who govern what software runs on full nodes, right? When I'm talking about full nodes, I'm talking about nodes that download blocks, relay transactions, verify blocks, relay blocks. Usually, you will run a full node if you are providing a service on the network. if you're, say, an exchange, a block explorer, even if you have an application, a lot of people run full nodes just to do transactions themselves or for their own applications. And every full node operator is basically limited to downloading software from consensus-compatible software repos. So while they, at the end of the day, will decide what software runs on the network, they're limited to only the selection of software that's available to them. And so while they, in some way, are the ultimate decision makers, they only have a limited amount of decisions that are possible in practical terms. So most full nodes actually just listen around and try to do what their peers are doing. They try to figure out where their community is going and install the same software that they do. Because the blockchain is interactive, right? It's a peer-to-peer software. You want to be with your peers. You listen to where your peers are and you try to install there. But for some minority of nodes will be uncompromising, and they're just going to pick whichever fork is more aligned with their philosophy. And there's kind of like a, so therefore what I'm saying is like the full nodes are going to talk to each other to decide, the full node operators are going to talk to each other and try to hear from the community what fork they're actually going to, what fork they're on in order to decide what fork to run. Miners, very similar kind of position, only they might elect to mine in a mining pool, in which case the mining pool operator becomes kind of their node operator. And they are, however, not going to listen so much to their peers as much as they are going to listen to their profit motive. And they're just going to follow and mine on whatever is most profitable. So the Geth and parity code bases basically make decisions which are patches to their software, which are like like diffs, pull requests merged into their repos, in order to maintain cross-shard compatibility. Right? They really don't want to have this kind of loss of cross-shard compatibility. And they have devs that participate in this thing called the alt devs call, which is we're going to talk about next. And that's where they kind of agree on what to install. And basically, but the important thing to note here is that like Geth and parity and every other software implementation of the Ethereum protocol is governed separately. Right? They have different teams, they have different administrators, they have different kinds of, they're literally separate resources that have to have separate governance processes. The alt devs call is this really remarkable kind of process. It's a or institution even. It's like a bi-weekly call, or bi-monthly, I don't know how you think about it, on Fridays, where basically the developers come to unanimous consensus, like every single time except for once, on the kind of short-term rollout kind of for features for the different clients, especially with respect to consensus critical ones. It's like, Vitalik's invited anyone who's a core developer of any main implementation is invited. There's someone from the Ethereum Foundation who keeps minutes and keeps the agenda. The Ethereum, the alt devs call reviews Ethereum improvement proposals when they get to a certain level of maturity. So the Ethereum improvement proposals system is basically it's a GitHub repo called EAPS where you can post an issue if you have a GitHub account, which if you format it in a certain way, it'll get treated as an EAP, which is an Ethereum improvement proposal. And it basically, the Ethereum improvement proposal process is a process by which you get peer review and development of these proposals to a point where they can actually be addressed by the alt devs call and therefore actually make it into the implementations and eventually into release. So it's not clear at the moment exactly what mix of like attention, review, maturity is required for an EAP to get into the alt devs call. There's a kind of a secret sauce or something. So the roadmap is another really interesting institution or part of the governance process for Ethereum that that basically kind of sets the long-term outlook. It's not really that tightly linked into the alt devs call by any means, but it will produce like papers and EAPs that eventually will lead to things that the alt devs will and eventually may lead to like implementations on the main Ethereum network. The roadmap is is probably one of the least formally governed process like parts of the process. It's kind of very, very pure on like technical merit of research questions, and we have like kind of very objective discussions. We don't really let incentives play a part in this at all. and we try to make it a really kind of scientific kind of process. And so here's this great little representation of all of this. So thick arrows represent a lot of influence, and small arrows represent a little influence. On the left here, we have the full nodes and the miners who ultimately make the decisions of whether to install one fork or another of the software. These geth and parity are examples of implementations of the software that are available to these nodes. Right? The miners are influenced a lot by the full nodes, but not so much vice versa, because the full nodes have the economic majority and they determine the price much more than miners do. Miners just kind of follow along. The all devs call feeds into both of these processes, and the EAPS process feeds really strongly into the all devs call, and the roadmap kind of feeds in there. And actually, the geth and parity team talk to each other, and the discussions between the teams also like feed into the things that happen in all devs. So somehow this is like a rough description of different parts of the Ethereum governance process and how they link together to produce, you know, ultimately decisions about what software runs on what nodes. So, is it legit? What's up with the legitimacy of the Ethereum governance process? Well, we're going to take it a little step at a time. So for maintenance and recovery, so far, I mean, firstly, let me say all this is kind of my opinion and from my perspective, and people have different perspectives on questions of legitimacy. But basically, like from the point of view of maintenance and recovery, I think things have been quite good. I mean, the Ethereum implementations have gotten a lot faster over time. There was like a consensus failure after this one hard fork to fix a DDoS issue, and it was dealt with in a couple of hours. And there were bugs where nodes crashed, and those were dealt with pretty quickly. There's the DDoS thing was dealt pretty effectively. So I think for maintenance and recovery, I haven't heard too many complaints. Actually, the least complaints out of everything in terms of people feeling disenfranchised by that process. For the technical upgrades, I think the EAPS process is actually quite respected and used. Maybe not enough. A little comment I left there. But stakeholder, basically anyone who believes that proof of stake and sharding are going to be the future of Ethereum and that's like going to work, is more or less like happy with the technical governance process. So I think for the most part, we were kind of set up. The governance process is kind of set up to handle these things with a lot of legitimacy. Because if you have an opinion about these things, then you can kind of get involved and participate at a certain level where you really can be quite happy. So basically, like the maintenance and recovery kind of tends to happen like here, and the technical upgrades are kind of like over here. But the all devs kind of pinning it, like kind of being this like one like central place that kind of is responsible both for maintenance and recovery and tech upgrades. So I think, but nonetheless, I think all of this actually could be improved with more education. I think if people realize, like, we're able to look at this picture more or think about governance more, they'd think that it's more legitimate just because they would see why it would produce outcomes that are aligned with their interests. And I think more participation also leads to more legitimacy because they feel because it leads to actually better outcomes. However, for ethically motivated hard forks, it's a little bit more controversial. For example, the DAO hard fork, and now there's like kind of hush-hush conversations about a potential parity stuck funds hard fork. It's easy to understand why people find this more unsettling, right? They definitely represent some interests of some stakeholders, but they also really raise procedural fairness questions, right? It makes people afraid that some people are just get to control what happens on Ethereum. And it's totally fair, right? I mean, why would some fork happen and not some other fork? And if you don't have any transparency, you don't have any reason to think that it's not just Vitalik calling the shots. But if we look at the structure, we do know that there are some clear limits actually on what could be done with a hard fork, right? I mean, nothing that the nodes would ever wouldn't install, would ever make it. And at the end of the day, we did have this precedent where with the DAO fork, where basically all devs decided to implement a flag which nodes could use to run one version or another. And so if we have that, then at the end of the day, it will be the nodes who decide. And only things that actually can be pushed through, that nodes will believe that other nodes will actually install, could actually make it through the hard fork as a hard fork. But here I think there could be a lot of work. Basically, I think if we want to have ethically motivated hard forks, then we definitely need to be sure that the legitimacy of the Ethereum governance process isn't damaged by them, right? We can't be doing these forks at the expense of the legitimacy of governance, because legitimacy of governance is really important for making sure that the blockchain will kind of continue to be governed well, that people will participate, and that people won't kind of revolt and fork and have these really kind of unhappy, warring kind of situations. So, I think partly again education and participation can make a big difference. And I think that like one kind of thought that I have is basically that like if we separate ethically motivated hard forks from technically motivated ones, then maybe we can experiment with ethics and blockchain governance without sacrificing the legitimacy of the technical governance process. And I think that's kind of just a thought. I don't really want to like make it much more than that because I think that it's really actually quite risky to come up to formalize and try to institutionalize policies, because you could be wrong. So I'm going to share a few governance pet peeves, a couple slides, and then I'll be really done. Sorry. So basically, this is my biggest governance pet peeve. When people want a formal governance system that basically solves the governance process by removing the right of nodes to decide what software to run, right? This is like Tezos or anyone who wants to have an in-protocol governance thing that will automatically determine what software people run, I think is robbing nodes of their roles as participants. And I think that that's really quite scary because one of the only reasons why I know that this system will represent the interests of nodes is because nodes have the key governance decision about what software to run. And normally this is done by plutocracy, which I think is equally quite bad. I mean, I think that the idea that we should have the coin holders govern the blockchain is akin to saying that we should have a blockchain with owners, like as stakeholders essentially. So, I'm also really not into when people advocate for developer accountability in blockchain governance without realizing that the structure of governance actually really restricts the power of developers. A lot of people, especially like lawyers and concern trolls, are, think that there should be more accountability for blockchain governance, but actually, like they don't. A lot of them think that, like, basically they're Vitalik decides kind of people. They think that like there's really just like a small number of people who are just deciding these outcomes. They're not really appreciating the structure and the constraints that are kind of placed on everyone by these processes. And also another one of the big pet peeves is anyone who propagates norms that make blockchain governance less effective. Like anything that removes power from blockchain governance just because blockchain shouldn't be governed, like the no hard forks thing. Anything that, the no hard forks thing I think is like a great example, right? It just prevents technical upgrades and it prevents any kind of ethical hard forks also. So, wrapping up, basically, blockchain governance exists even if there isn't a formalized system. It's fundamentally, there is going to be a governance process, and it's going to have structure that limits the power of participants. The norms and precedents actually can easily become a part of the structure of governance, just through this kind of process of common knowledge and expectations. Finally, a legitimate governance process is a happy governance process, right? I think that legitimacy of our governance processes need to be defended, and we need to make sure that like we can continue to have justifiable legitimacy in these processes, that people like should believe that they will represent their interests, not just they believe it because we propagandize them. But really, like they should believe because there's a reason for us that the structure would lead to decisions that represent their interests. So basically, I want you to learn how hard it is. Sorry, I want you to learn how blockchains are governed and use the ones that are governed responsibly. Right? Just pay attention to the governance processes. Like figure out like how the decisions are made. Like what's the structure? What are the participants? What are their incentives? Do people believe this is legitimate? Right? Will people go along with the decisions? There's all sorts of questions that you can ask. And then you should pick the governance processes or the blockchains that have governance processes that you believe in, right? That you think that are actually going to be representing your interests in the long run. And finally, like blockchain governance is hard, right? So institutionalizing your favorite governance ideas is probably not the way to go, right? You probably shouldn't be writing a blog post saying this is the way we should govern Ethereum, right? Instead, right, we need to be like thinking a lot about the current structure and the current participants and like what norms already exist and what structure already exists, and try to make some much less risky kind of evolution rather than to just institutionalize your favorite idea about how governance should work. So that's my call to action, my call to caution. So now I'm done. Thanks a lot. Thanks a lot for listening.
Let's welcome a man with no introduction, Vitalik Buterin. So before Vitalik started, a short reminder, we'll have a Q&A section after the talk. So make sure you have your question in mind. If you're being picked up, we'll let you to ask your questions. Okay.
Okay. Hello everyone. 大家好。我会讲中文一点点，但是我的中文讲得不太好，所以我今天要用英文演讲。So Ethereum 2.0. So this is, so first of all, there isn't really a kind of precise conception of, what goes into Ethereum 2.0, what doesn't go into Ethereum 2.0. So it's Ethereum isn't kind of a product that gets released by a company in the same way as, Windows has version 7 and then version 8, and then it skips version 9 for some stupid reason and it goes to 10. It's more like, this is more like something that's just going to end up slowly evolving over time. But even still, though, there are very major changes to Ethereum's architecture that we do expect will come over the next few years to focus on some of the problems that I'm going to talk about in this talk, including things like scalability. And so calling what Ethereum is going to look like over the next 3 to 5 years, Ethereum 2.0 is still probably a fairly reasonable thing to say. But it's, in general, basically, this includes things like Casper, this includes things like sharding. And for this talk, I probably will spend most of the time actually talking about sharding. But basically, the idea is, what is the protocol going to look like in the future? Right? So, first of all, what do we mean by Ethereum 2.0? What is Ethereum 2.0 going to be? And I think the answer is pretty obvious. Yeah, no. Ethereum 2.0. Look, the Ethereum killer is Ethereum. The Ethereum of China is Ethereum. The Ethereum of Taiwan is Ethereum. 2.0. So, look, how is Ethereum itself going to end up solving these scalability problems, privacy problems, all of the various issues that Ethereum has today? Well, first of all, let's talk about what some of the big problems are. Right? There's generally 3 major categories of problems that I just keep talking about every year. And the reason why I keep talking about them every year is because they are big problems, and they are very important problems. And these problems are problems that take a long time to solve. And until they get solved, they just continue being the most important problems that we have, right? So, just like in real life, the most important problems include things like climate change and the fact that we still die after less than 200 years and a few other things. But, and hopefully that'll be solved fairly soon. Here we have, number 1, privacy. And blockchains are public ledgers. And the problem basically is that, on the one hand, the fact that a blockchain is a public ledger is a good thing because it means you have lots of nodes verifying data. But on the other hand, blockchains are public ledgers, which means you have lots of nodes seeing data. And it seems like there's this paradox where, on the one hand, you need to have lots of nodes verifying to have security. But on the other hand, you do not want to have lots of nodes seeing because that compromises your privacy. And there's a question of, well, how do we resolve this trade-off? And there's a bunch of ways to do this, including things like mixers, including things like state channels, also including some kind of higher tech cryptographic alternatives. And the Byzantium hard fork that Ethereum released about 5 weeks ago introduces support for some fairly fancy new cryptographic algorithms, so things like zero-knowledge proofs, some ring signatures, and so forth, that don't fully solve the privacy problem on their own, but do give us some very powerful tools on top of which we can start building the solutions. So from a base layer perspective, I actually think the privacy problem at this point is maybe 3/4 of the way to being solved. Maybe the 1/4 that isn't solved is that there's still leaks on the protocol layer. Like, for example, if you use a mixer, then if you use Ether to pay for gas to get your money out, does that turn into a privacy leak, and a few other small things. But most of the work from here, I would say, is at layer 2. Consensus safety, so making the consensus algorithm safe, and also allowed consensus algorithm efficiency, making the consensus algorithm more efficient. Unfortunately, like Bitcoin proof of work mining consumes apparently more power than more than half the individual countries in the world, and Ethereum unfortunately isn't much better. But once again, climate change and just generally wanting to be efficient, good human beings, we want to have a consensus algorithm that wastes less electricity. So proof of stake, smart contract safety. So basically, consensus safety and going from proof of work to proof of stake has to do with basically not throwing $1 billion into a hole every year because of mining. Consensus safety has to do with not throwing $200 million into a hole every year because of smart contract bugs. So and this includes things like formal verification. It includes things like better programming languages and a bunch of other things. So these are all very nice and interesting topics, but today I'll probably focus on the most fundamental of all of them, which is the scalability problem. Now, why is scalability so hard? I often talk about the scalability trilemma, where I say that blockchain systems have to trade off between different properties, and it's very hard for them to have 3 things at the same time, where one of them is decentralization, the other is scalability, and the third is security, right? So the problem is, it's fairly easy to have 2 out of 3. So for example, if you want only security and decentralization, then you just go for existing blockchains. Ethereum, Bitcoin, Bitcoin Cash, Dogecoin, all the same to me. Basically, that is the status quo. Now, the other thing you can do is you can go for decentralization and scalability at the cost of safety. So what this might look like is it might look like some kind of super client that would connect to all of the 1 to 5,000 blockchains that exist today and just try to route transactions through whichever one currently has the lowest transaction fees and come up with a bunch of very efficient decentralized exchanges between them. This works, and this is very decentralized, and this is very scalable. But the problem is that you're basically balancing between 5,000 blockchains, each of which is, relatively speaking, fairly insecure. The other thing you can do is you can sacrifice decentralization. So this includes kind of super big blocks. And to be clear, I'm not talking about going from 1 megabyte to 4 or whatever. I'm talking about going from 1 megabyte to 10 gigabytes. So that sacrifices decentralization. Master nodes. So, some concept where you have a blockchain and you have one class of nodes, and then you have this other class of super nodes that kind of actually have all the power, and where you need to have $100,000 in a data center to become one. Consortium chains are another great way to get scalability and safety at the cost of decentralization, and other similar things. But, can we not sacrifice one of the 3? The other category of solutions that people talk about a lot are second layer solutions. And there's a few kinds, right? So one of them is interactive verification. So basically things like TrueBit, things like Golem. It's generally these blockchain protocols that try to use blockchains to kind of verify computation in clever ways without actually doing it all of it on chain. Now, this is very useful for a lot of applications, but actually not that many applications, right? If you want to do heavy computation, then it's good. But the place where it starts failing is where it's not just heavy computation that you're dealing with, but also heavy amounts of data. So basically, the problem becomes something called a data availability problem. I have entire talks on this. Feel free to look it up. It's hard. Now, the second kind of solution is things like Plasma and state channels and Lightning and Raiden and this general kind of big category of things. These solutions are nice, and they can provide quite a bit of scalability. But one problem is that their throughput is still limited, right? And it's still limited by basically the main chain's ability to handle deposits, the main chain's ability to handle withdrawals, and the main chain's ability to handle attacks. And also, it requires much deeper reasoning about kind of the game theoretic properties of the mechanism that you're building, which makes it, I would say, significantly less generalized as well. So our goal is a bit more ambitious, right? Bear with me here, right? Yeah. So, we want to scale to thousands of transactions per second on chain without super nodes, master nodes, crazy server nodes, consortium chains, or any of that stuff, at least at the base layer. So can we do this? Well, I believe that we can. So the core kind of model here is this concept of sharding. And the way that I generally describe sharding is you can think of it as creating in a fairly simple version, creating a blockchain where you have, let's say, 100 different universes. And each of these universes is a different account space. So you can have an account in some universe, or you can have a contract in some universe, and you can send a transaction in some universe. And if you send a transaction in some universe, it can only affect stuff in some universe. And you might have some protocol for transferring data, transferring resources between these different universes, but it could be more limited than, it could be something asynchronous. It could have a 2-week delay. And generally, it's kind of not as clean and convenient as doing stuff within one universe. But these kind of 100 universes are not just separate blockchains. They are systems that are also interconnected with each other, and particularly they share consensus. So in order to break even one of them, you have to break the whole thing. So now this doesn't describe every possible sharding solution out there. And we can, kind of really ratchet things up on the margin and eventually make communication between these different universes really good, and possibly even blur the distinction between, going across universes and between universes. But this is one kind of simple way of thinking about it. Right? So how would an instantiation of this actually work on Ethereum, right? So we could try to think about, the very far end view of what the optimal system would look like, or we can try to think about what can we design fairly easily in the near term. And here's one example of something that we can fairly easily design in the near term. So let's imagine we keep the main blockchain, and into the main blockchain, we would publish a contract, and this contract would be called the validator manager contract. And what this would do is it would, first of all, maintain an internal proof-of-stake system. So it would maintain a system where validators, basically people with Ether on the main chain, can deposit their Ether into the validator manager contract, become proof-of-stake validators, and if they ever want to withdraw, they can withdraw. And the validator manager contract also keeps track of a set of shards. So these are these kind of 100 universes. And for each, during each kind of block or period or cycle or whatever, the validator manager contract assigns a random validator the right to create the next block on each shard. So, once again, there are a lot of variations on this, but this is just one kind of fairly simple way to think about it, right? So during every block, for every one of these 100 shards, some random validator from the entire set gets assigned the ability to create a block on one of them. Now, you would have each of these shards itself obviously has blocks and it has transactions, but we're not going to put all of those blocks and transactions into the main chain. Instead, what we're going to do is we're going to take the same kind of structure that Ethereum currently has with blocks, where you have like a big block that gets represented by a tiny block header, and we're going to just replicate it again one level down. Right, so at the shard level, we would have things called collations, and a collation is basically just a group of transactions, and the collation would have a collation header that would be basically like a proof of stake signed block header, and these collation headers would get pushed into the validator manager contract, but all of the actual transactions, all of the in the shards, all of the shard state, all of the shard the shard collations, that would all go off chain. The only thing that goes on-chain is these collation headers, and the validator manager contract would keep track of these headers, and it would keep track of the state state roots of each shard. So there is kind of this division of labor here, right? Where basically the validator manager contract just acts as a light client for each shard. Like that's probably the simplest analogy here that you can think of. So the scalability of basically you would have these two different worlds, right? You would have the main chain, which keeps on working, keeps on having the same scalability as it does now, except you would also have this new world that gets created, right? And you can try to compare these two worlds with a few properties, right? So the first thing you can compare is scalability. So my usual notation for scalability here is that the letter C basically represents how much computing power one single node has, right? So remember, we hate master nodes, and so we want Ethereum to theoretically be able to exist and process Visa scale transaction levels with nothing but a set of consumer laptops, right? So C is the amount of computing power that can be processed by a consumer laptop. So on the main chain, the scalability is O of C because every transaction in every block actually has to be processed by a full node, and a full node has to be able to run on one of these. Now, in the new shards, you might notice that first of all, what you have is a set of universes, and for each one of these universes, the collation headers still have to go into the validator manager contract, which is part of the main chain. The main chain has a capacity limit of O of C. Therefore, the total number of shards is still limited by, like roughly O of C, right? So basically, the number of shards is proportional to the amount of computing power of a node. Now, within each one of these shards, you would have these collations, which are like shard blocks, and a node has to be able to process at least the collations on some shard that it cares about, right? So the capacity of each individual shard is also limited to O of C. So the capacity of the number of shards is proportional to the computing power of one node, and the amounts that can be processed by each shard is proportional to the computing power of one node. And so the capacity of the whole thing is O of C squared. Goes up quadratically with the computing power of one node. Now, there are ways to make sharding systems that go up to O of C cubed, O of C to the 4, and potentially O of, like 2 to the power of C divided by some constant, which is like the holy grail, but we're not going to talk about this here yet. And in fact, if we want to go that far, then that would probably be more Ethereum's 3.0 territory, which would involve fancy stuff like Starks. So that's scalability. Consensus. Now, consensus on the main chain is proof of work now, and it's slowly moving toward proof of stake. In the shards, the consensus for the shards, so first is going to be basically proof of stake as mediated by the validator manager contract, which sits on the main chain. So basically, it's this kind of indirect second layer consensus algorithm that sits on top of the existing main chain. Governance. So the main chain will continue to be governed by hard forks, which are like the best possible way to govern protocol changes because they give users choice, right, Vlad? Okay. And the new shards are basically governed by kind of Ether voting through a validator manager contract, and basically this plus, of course, the users of the shards would also have to download updates in order to accept them. So it's like it gives the users in the shards somewhat less control, but if they still end up having having some level of control, right? So this is in the this is all in the early stages of the sharding system, right? Basically, the roadmap would be that in we would start off by releasing this kind of minimal version of sharding, then add two-way convertibility of Ether. Then eventually we would reorganize the system so the shards would kind of be in a more logical position in the main chain. Basically, they would be uncles instead of being transactions. And then the fourth step would be something called tight coupling. And tight coupling is where we say, basically, we kind of, the community officially says and agrees, and everyone downloads, clients that enforce that if a given blockchain contains a shard header which is invalid, then the blockchain as a whole becomes invalid. So basically, tight coupling is where the validity of layer 2 becomes becomes a necessary condition for the validity of layer 1. And once you have tight coupling, then basically the entire sharding system would have kind of the same uniform level of security, and it would all basically be governed by hard forks and not really any kind of ETH voting mechanism. So this is what it would kind of in the medium term turn into. And of course, over time, the sharding mechanism would continue being developed and improved. Eventually, there would be new sharding designs. Eventually, there would be Ethereum 3.0 that adds Starks, that adds multi-layer sharding. That would eventually this would add stronger and stronger forms of cross-shard communication. And these are all things that can kind of continue getting incrementally added and bolted on over time. So the way that it would work initially is basically that if you want to participate in the sharding system, then you would run an Ethereum node, and this could be a full client or a light client. It would connect to the Ethereum network, and you would also run a kind of sharded chain node. And the sharded chain node would connect to your Ethereum node by RPC, and it would also talk over its own peer-to-peer network in order to broadcast things like shard transactions, shard blocks, and shard collations, and so forth. So it would start off with this kind of separation of concerns, and then, of course, over time, eventually, the two would, once we move toward tight coupling, the two would kind of merge together. So one important note here is that with this model, the shards are creating new address space. They are not affecting existing address space, right? So what this means is that this gives us an opportunity to do a bunch of important kind of innovation and a lot of important and much needed but backwards incompatible improvements to the protocol by basically turning on those improvements only inside of the shards. Now, of course, at some point the main chain would needs to be upgraded, but we can basically figure out how to do that later. Like there's no need to have a backwards compatible upgrade mechanism for the main chain be something that slows down access to the to this sharding mechanism for newly created applications. So, do what? No. So the shard nodes might be subscribing to different shards. So you might be on, like in general, right? Unless you're actually running a data center, your shard node would not be able to fully subscribe to every shard simultaneously. So you would generally have to choose, like one to a few shards to subscribe to, and then for every other shard, you would basically be a light client.
What happened actually
That depends. So when I give you my Ether address, the Ether address would say what shard the account is on. Yeah. So now some of the changes here include things like switching from hexary Merkle trees to binary Merkle trees. This makes Merkle proofs 4 times more efficient. Faster EVM. We could basically go straight into something like EWASM. More parallelizability. There's like 5 different possible ways to make the Ethereum virtual machine way more parallelizable. And one thing that we're looking at is this idea called stateless clients, which basically means that like the clients themselves don't have to keep track of the full state of the system, and instead, like basically, instead of requiring clients to have state, we would require transaction senders to provide kind of Merkle proofs of specific portions of state that they access. Now there's still like a lot of different ways to implement this, and there are a lot of details of this kind of scheme that are still up in the air, but this is just an example of the sort of thing that can be done inside of a sharding system. Now, why can't we do a lot of this on the main chain? Well, because there are a lot of backwards compatibility requirements, like for example, there's a lot of contracts that require the ability to just arbitrarily, dynamically access one particular address. So it's this sort of thing is significantly harder to do on the main chain, because if we do this to the main chain, then we would basically be kind of fairly seriously violating kind of application immutability in a lot of cases. But if we do this for shards specifically, then basically it's a clean slate, and a lot of this can be done much more easily. So conclusions, right? The idea behind this kind of design is that, first of all, ongoing protocol development would get split into 2 layers, where the first layer is safe and conservative, and probably more safe and conservative than it has been for the last 2 years. The second layer would basically undergo rapid development for some period of time, and then at some point in the future, it could kind of crystallize a bit more and become more safe and conservative as well. But like that's the sort of thing that makes sense for a mature protocol. It doesn't really make sense for an early stage development protocol. Release early and increase security over time. And with sharding, we also get fairly easy, kind of immediate access to quadratic scalability, which is basically how you can get, possibly in the thousands of transactions per second with a network that runs on laptops. And there's initial work that's already being done for a lot of this. So thank you, and if people want to ask questions, I'm here.
A section. If you have any question, please raise your hand. We'll deliver the microphone to you. Any questions?
All right, so on releasing early and increase security over time, I would think of going the other way. So I would think that you would release with maximum security, and then you'd sort of like slowly reduce some of the...
What do you mean by security, though?
Well...
like, how do you release with maximum security? Because maximum security is like the hardest thing to do.
Sure. Okay. Well, I'll give you some examples. So for the block proposer, there's a couple designs, and some scale better, and some have better security properties. Okay. So, and we're saying, well, which one to do? And so I was thinking, well, let's go with the ones that have better security properties, and then just hopefully it doesn't break. And if it doesn't break, then we can slowly kind of loosen it up a little bit such that it scales better.
That's possible, though that's not the sort of thing that's possible in every context. So for example, like the concept of sharding as a whole is something that's inherently much more experimental, and it does so in order to get scale, right? So there are, and additionally, there are ways to get sharding with kind of medium security that are fairly easy, and there's ways to get sharding with high security that are more advanced. So and then there's also ways to get, actually, you know what? No, never mind. I would say we're combining both philosophies, because on the one hand, like we're moving from loose coupling to tight coupling, which increases security, and we'd probably add fancy stuff like data availability proofs. So that's kind of starting low security, going to high security. And the second thing is that we're starting with quadratic sharding and then eventually going to exponential sharding, possibly. And this would be an example of us starting safe and conservative and then moving to something more ambitious once the simpler versions prove themselves.
So you want to go both ways?
Yeah, totally.
Huh.
Virgil, I have a question to you. Why are you wearing pink?
Oh. I don't know. I'm strutting my unicorn.
Answer accepted. Okay.
Thanks. I think the idea of shards and sort of this, I call this like two-speed Ethereum is quite exciting. The question is like, can you envision a world where each of these different shards or different universes is like a space where we can test various things, almost like A/B testing, and just as one example, like testing different governance protocols or mechanisms in different shards to kind of see what sticks or what works?
I mean, it's definitely possible. Though so first of all, and it's definitely very possible to just have multiple validator manager contracts running at the same time, right? So, like the Ethereum community could have a social contract that says, like these are kind of the 5 validator manager contracts that we kind of bless, and we as a community would give this kind of important backstop where we say if one of them screws up, then we can hard fork to fix it. And then those become kind of the 5 sharding systems of Ethereum, and eventually we might decide to enshrine one of them. So that's a totally theoretically possibly legitimate thing to try to do. In the long term, I personally believe that sharding should be homogeneous, basically for the same reason why like C++ is homogeneous. It's just basically there's no there's in the long run not too much need for heterogeneity when you have Turing completeness, though there are designs where it makes sense to have a homogeneous model with heterogeneous parameter choices. So for example, like Vlad has brought up ideas where you have something like shards numbered from 1 to infinity, where the lower numbers have higher fees but also higher security, and then the security kind of goes lower and lower, and you choose what trade-off you want. So there's a lot of interesting ideas around that too.
It gives us an interesting option for people who might otherwise want to sort of fork Ethereum and sort of do their own thing, right?
Yeah,
they can kind of have their own little playground or like an autonomous region, so to speak.
In the long run, it's totally, it could be a totally fine governance model where basically we can be fairly liberal with creating these validator manager contracts and then later on decide which one to enshrine. Lena, question back to you. Why are you wearing gray stripes?
Because I don't have a shiny costume to wear on stage, a unicorn yet, but I will for the next one.
Okay. Yes, Changwu.
Okay. So how do you see a startup company in Singapore called Zikra? They are doing the transaction sharding.
Zilliqa?
Zilliqa, yeah.
Yeah, so Zilliqa is doing partial sharding, where they do sharding of transaction handling but not state, which is still a kind of fundamentally fairly limited kind of sharding, because if you have 1,000 transactions a second, then that goes up to having billions of accounts, and so you still need terabytes of storage to run a full node. So it's that kind of approach can give you 1 order of magnitude, maybe a bit more, but it does still introduce leave storage as a bottleneck. Whereas here we're going for kind of maximally ambitious shard literally everything. No.
Hello. Yep. Yeah. So how could sharding affect applications that are already running on Ethereum? So what are the things that developers need to do in order to support all the accounts on different shards?
First of all, there's going to be a few different kinds of applications, right? A lot of the smaller applications will probably just live on 1 shard. For more advanced larger scale applications, chances are the way that they will work is they will probably just publish 1 copy of their master contract on every shard, and then basically there will be users will have accounts on 1 shard, and they will be able to basically send to the contract on their local shard. The application might have built-in ways of communicating between its different instances, and it is fairly once you build applications that stretch beyond 1 shard, it does become more application specific, because there isn't one way to scale. There's different ways that have different trade-offs, and I expect the developer tools for that should kind of improve and get better over time. Although I don't actually think the developer tools necessarily need to be that complex. mainly because like the only thing you would really need to do is like add some kind of asynchronous programming capability. So it's once you have that, then that already resolves a lot of the issues. Like with async, like if you build your entire application so that it's async, then basically you don't even need to think about kind of which shard stuff is happening on, because it's just all async transactions. Yeah.
Excuse me. After implementation of Lab 2.0, do you think Ethereum can handle the real-world financial transaction just like a Visa 4,000 transactions a second?
Yeah, I mean, I personally believe so, right? So I personally believe that Ethereum 2.0 with quadratic sharding can go up to those levels, and then if on top of that you add like various layer 2s like like state channels and plasma, then that could give you another maybe 2 orders of magnitude, and then Ethereum will be good enough to handle like most very significant applications. And then if we go from there to like super quadratic sharding, then I mean, if people really want to, you could just handle everything on the base chain, but like the research for that is still a bit further out and depends on very spooky stuff like Starks. Yeah.
Is the mechanism of sharding providing security similar to the mechanism of merge mining like Litecoin or Dogecoin, or they are totally different?
No. So merge mining and sharding are quite different, because with merge mining, in order for one particular chain to benefit from one particular miner's security, that particular miner has to be a full node on that chain. And so with merge mining, there actually is a trade-off between everyone merge mining every chain, in which case it's basically as decentralized as one chain having 10 gigabyte blocks, and on the other hand, every miner only merge mining a few chains, in which case it's basically like altcoins. Whereas with sharding, you have this kind of random sampling mechanism with a couple of other mechanisms as backstops, basically like fraud proofs, data availability proofs, and a couple other things. The idea being that even basically you would have both, where you have both the facts that like on average every node only needs to process a small portion of transactions, and it's the case that to break even one shard you have to break a large portion of the entire system. Okay, 还有问题吗？强木，你为什么穿黄色的 T 恤？好的，穿黄色的 T 恤。Okay. Okay. Done.
Okay. So please welcome. I'd like to invite all the speakers we invite today to go to the front of the stage. Organizers have prepared a small gift for you to show you that we're very happy that you're here with us.
Yeah, so please, speakers, please come over the stage. And our friends from ETH fans, please come over. Thank you. And I would like to invite our friends from Ethereum Foundation, Changwu and Xiaowei, to help us to give the present. Is that okay? Yeah. Would you guys please step more, front? Yes, thank you. Yeah, like here. Thank you, thank you, thank you. Yeah, don't be shy, don't be shy. Yeah, thank you, thank you. Yeah, please. Yeah. Yeah. One liner, please. Yeah, thank you. Yeah, so where's the gift? Yeah. All right. So just deliver the gift. Yeah. So guys, claps. Woo! Yeah. And really special thanks for the Ethereum Foundation members, because that's why we can have this kind of awesome event like this afternoon and this morning. Yeah, so yeah, it's a great talk for you all guys. Thank you. And welcome to Taiwan. Yeah. All right. So we can have a picture, I think. Yeah. Wait. Yeah. Okay. And we have one guy left. Oh, yeah. All right, so can we step 1 foot left? Because lights here. Yeah. And one more, please. Yeah, thank you. And one more? Yeah, guys. And we would like Ethereum Foundation members from Taiwan, please come over. Have a group pic photo. Yeah. Okay. All right, picture time. So who is gonna do the first? All right, see the camera. So yeah. And next. Which one? All right, see this camera. Yeah.